Good morning, everyone. Nice to have everyone here. Actually, I should rephrase. We're having this live around the world. Good morning, good evening, General ZM, GM. I'm Hudson, VP of Community at Polygon Labs. Also voted handsomest L2 rascal by Time Magazine this year. Very big honor. Didn't even know Time Magazine cared about layer 2 technologies. So we're having today the aggregation day, and we are also going to be talking to people internal to Polygon Labs. We're going to be talking to people who have built this, talking to people external to this about a lot of cool stuff. We are very, very excited about today. So we're going to go ahead and get started. I'm going to see if the screen share works. And it does, the magic of live streaming. So, yeah, what we're going to do is go ahead and invite people on stage here. Let's see if they made it in.
You send people over, right?
Yeah.
There we go. All right, Brendan up here first. Hello. Brendan Farmer is a co-founder of Polygon and a works on Polygon Zero. So, Brendan, go ahead and take it away.
Oh, great. Thanks, Hudson. Can we get slides up? Are there slides or? Hey, Jordy.
Oh.
Hey.
Okay, so slides. I'm actually not able to see the slides, but all right. So hey everyone, I'm Brendan. I'm from the Polygon ZK team, and I just wanted to talk a little bit about the blockchain. So a couple weeks ago, we published this post, and in it, we made two claims. So the first is that no single blockchain is capable of supporting the throughput required for an internet scale crypto ecosystem. So this is sort of a challenge to the monolithic view of scaling. The second claim is that even if we add block space and scale horizontally, if we do that while fragmenting liquidity and state and users, then we failed in some sense. So like when we talk about scaling in crypto, we really mean scaling access to liquidity and to shared state. And so this forms the basis for the aggregated blockchain thesis, which is we need a horizontally scalable multi-chain ecosystem, but we need to be able to have that while preserving unified liquidity and shared state and composability. So the sort of the upshot of this is that Polygon has released this vision for the aggregation layer, which we view as like this foundational piece that will allow us to provide this. So a multi-chain ecosystem that still has unified liquidity and state and composability. And so next slide. I can't see the slide, so I hope that it's the next slide. But and so when we talk about unified liquidity, in my mind and in Polygon's mind, that has two components. So the first is asset fungibility. Like if I'm in the Polygon ecosystem or this multi-chain ecosystem around the aggregation layer, I should be able to take ETH on ZKVM, and I should be able to bridge it to like the OKX chain or like A-Star or Manta or Canto, and I should get ETH on that chain. I shouldn't get wrapped ETH. I shouldn't have to rely on liquidity providers to swap me back into the native token for that chain. And so the second component, the second requirement is fast cross-chain transactions. So right now, if you think about how rollups and cross-chain rollup transactions work on Ethereum, I need to, in order to send a message from rollup A to rollup B, I need to first submit my transaction to rollup A, generate a proof, wait for that proof to be submitted to Ethereum, wait for that block to be finalized on Ethereum, and then finally rollup B can accept my cross-chain message. And so this doesn't work for unifying liquidity and shared state. And so the aggregation layer, and next slide, is proposed as a solution for this. So right now we have this fragmented L2 ecosystem, and if we continue along this path, then even with 1 million rollups, even with like as much block space as we could possibly use in the world, we still will run into this issue where we have liquidity and state that's fragmented across all of these rollups. We need a way to unify that environment and make it feel like using a single chain for users and developers. So fundamentally, the aggregation layer is a decentralized service that sits sort of beneath the L2 chains in the Polygon ecosystem. So it allows for safety for asset fungibility and super fast cross-chain transactions. And it allows for all L2 and L1 native assets to be deposited in a single unified bridge so that I can have like L1 native ETH on ZKVM, and I can move it to ZKPOS or to the OKX chain, and I can get back L1 native ETH on that chain. Similarly, for any L2 native asset, I can take that asset and I can move it between chains really, really fast. And fundamentally, I can do so in a safe way that doesn't jeopardize the assets that are deposited in the bridge. And I can do so without requiring an L1 interaction. And so for us, like the aggregation layer is kind of this foundation that provides safety. And then we envision sort of an emergent ecosystem of coordination mechanisms like shared sequencers, like relays, like builders that allow for this cross-chain interaction to happen. But fundamentally, they can do so in a safe way. Users and chains don't have to trust these actors to not misbehave. They don't have to trust the aggregation layer. And so they can transact in like a super low latency way without additional trust assumptions. And so next slide, please. So today, the sort of upshot of all of this is that the first component of the aggregation layer, which is the unified bridge, is live today on mainnet. The LXOY bridge contracts have been deployed, and this is sort of the basis for additional CDK chains to plug into this emerging ecosystem. The second milestone is going to be proof aggregation, and I am really glad to have Jordi here to talk in detail about proof aggregation.
Yes, thank you, Brendan. Yeah, in the core of this aggregation layer is this proof aggregation. I mean, proof aggregation is very much exploring the recursive snarks technology. Recursive snarks has been theoretically set for a while, but practically has not been. So the space has not been putting this technology in practice until the ZKVM launched. Actually, in the ZKVM, we are using a lot of these aggregations. When we are taking many batches and we are aggregating together to a single proof that prove a segment of a blockchain that includes different batches. So mainly what we are doing is we are taking a batch of a proof, another batch of another proof, another batch of another proof, and we are aggregating them together. Okay, so next slide. What we do in the aggregation mainly is using this technology of aggregating proof to aggregate many proofs of many chains. You can go to the next slide, please. Yeah, so here is we are taking a proof of a chain, another proof of a chain, and we are aggregating them together to a single proof. But we do that recursively. We take another proof and we aggregate them together. And then we take two sets of proofs and we aggregate them together. So at the end, maybe once per 5 minutes, we are taking all the proofs of all the states of all the chains. We are computing a single proof that proves all the chains, and this is the chain that we are setting that on mainnet. And because it's a ZK proof, we have the warranty that the state transitions happens in the right way, that the security of the full ecosystem preserves, and that everything works. But here the important point here is this proof, this ZK recursion, this proof aggregation that we are using extensively inside Polygon. Why is important this in the aggregation layer? Because you cannot, here all the point is that you cannot start using the funds in another chain until you are sure that those chains has been exited, that has been happens in the first chain. And the proof is the generating this proof is what rules it all. Okay, this compared, for example, with optimistic approaches, you don't need to wait for gamings on that. You just have the proof. You know that this is correct. You can go right. So here is the main topic. And yeah, that's very much what I wanted to explain about the proof aggregation.
Awesome. Mark, I interrupted and stepped on your intro talk because you were not on stage. Do you want to give it now?
Yeah, no, I think maybe setting the stage for some of this would be really good, right? When we really think about, well, first I just want to say, like, I think today's going to be a day that we are going to have some of the best ZK content that you can possibly get. And that's not just coming from our internal teams, but really awesome external speakers as well, which is really exciting. But what you just saw, right, is like the core of everything that we do is really ZK tech at Polygon. And when we were evaluating like paths forward from like a scaling perspective, what we realized is that ZK tech is going to be at the core of that. And when you take that one step further, what you realize is that there is a way to improve on kind of blockchain approaches that have been taken so far, right? And so like the two popular approaches, right, is like monolithic blockchains and modular blockchains. And we started thinking about that. We're like, okay, monolithic chains have problems that everyone recognizes. Modular blockchains have been viewed as like an improvement on that. But the downside of them is this fragmentation that you get. And so what can we do to bring them together, right? And I think we're uniquely positioned with the ZK expertise that we have to bring them together into aggregated blockchains. And you've heard a lot about like Polygon CDK if you've kind of followed Polygon at all. But what you've heard a lot less about is kind of the stuff that we're jumping in today. Brendan gave a good intro on kind of that first part of the ag layer going live. And that's a very core kind of first component of it. But there's going to be multiple stages to this. And Jordi talked about a very important kind of second stage of that, which really has to do with proof aggregation. And we're going to need to go even further than that to get to that low latency ag layer that we all want, and that is going to create that amazing user experience that people have probably heard us talking about. And so I'm kind of excited for us to just continue to explore that. I think kind of setting the stage with what the ag layer is and what that next stage would look like with proof aggregation is kind of like a really good start. And I think maybe we could jump in now to talking about what some of those kind of benefits to the ag layer are going to be. Brendan, if you want to kind of like take that away. Moderating it, I think that'd be a good place to head now.
Yeah, sure. Happy to, Mark. So I guess the first question, I'll direct this to Sandeep and Mihailo. What is sort of the end game vision? Like when you imagine this like internet scale crypto ecosystem with a ton of chains and like something that looks different from what we have today, like what do you see?
Yeah. Maybe I can start, and Mihailo, then you can take up. So I mean, for me, it goes back to the roots of when we started. And I have multiple times stated also that given a choice between like two architectures, which kind of takes us to a path where there will be some midterm great scalability, but then it is not the long-term solution versus a solution which is in the long run is going to be, it is the solution which can be the next this trustless internet or Web3 that we call. We'll always choose that. And aggregation layer is, or the aggregation mechanism, and with this Polygon ag layer, I think like all of us, first time we believe that this is one architecture which can actually scale blockchain networks to the scale of the internet without compromising the security of the system. And then there have been multiple kind of definitions of aggregation that has been given. To me, I feel that it's very simple, that all of these chains, these are all individual state machines, and then aggregation is basically aggregates all of those state machines into one single security zone. So we have also multiple times said that this becomes like looks like a single blockchain, where people are transacting. The experience is much more seamless and all that. And the other important part is be capitalistic in nature. That means now you don't need to be on a shared blockchain. If you are a developer, whether you are a large enterprise or a crypto degen builder, or you are a college student who is building some game or some experimental application, you can simply spin up your kind of chain, or I call them sometimes these trustless servers and all that, and connect it, provide your ZK proofs into the aggregation layer. Your chain is as secure as any other chain in the ecosystem, right? So that's like having that same security zone across big, large, small application. That's what like internet has provided today, whether it is a large scale website or web application, or there's a small application on the internet, they interact seamlessly together. Although there is the security, there is base security element, but this value security element is not there. With these blockchains, the security of the value element is also there. And I think it for me, it's like it looks very similar to the structure of the current internet, which is the trustful internet, and this architecture can provide the trustless internet future. So that's why Aggregate for me. Hello, over to you.
Yeah, I can pretty much second what Sandeep said. First of all, I'm very excited about the whole aggregation thesis, as well as all of you guys and the rest of the team. I think in our firm belief, it's the next kind of evolutionary phase of blockchain design or blockchain infrastructure. And it's definitely going to take us a step closer to that end game, basically, which is a globally scalable, internet scale, basically, a network of value, which is seamlessly interconnected and feels like a single network, just like the internet, as Sandeep said. So, not to go into through the genesis kind of and retrospective of blockchain design and approaches that we have taken so far as the industry. So from monolithic to modular, we really believe, again, that aggregation aggregated blockchains are what is going to take the industry mainstream, basically. And the end game or the goal here is this, as I have been saying multiple times, this global network of value. So with the internet over the past couple of decades, we have, as the society, we have been able to establish this global network of information, which has, as we all know, transformed the society in very profound ways, right? And it kind of democratized access to information and knowledge, and made the entire society more efficient, more interconnected, and feels like this really network of equivalent network, but for value is really the missing part. It's almost like, how come that we still don't have this, right? And with the blockchains, specifically with aggregated blockchain approach and design direction, we really believe that we're really kind of seeing the clear path to actually build that global network of value, which will, in our firm belief, transform the society probably in even more profound ways than the internet has. So that is kind of the end game, and very excited about everything.
Yeah, I think that's a really nice way to put it. And I should note that in response to the chat, Sandeep is not a fugitive on the run. He's just on his way to ETH Denver, and is currently, I believe, outside the Eiffel Tower in Paris. So, Sandeep,
not for fun. Like, I am at NFT Paris, and I had a key here, and I'm freezing here, right?
Give us since we literally can't hear a word that you were saying. Can we at least get a shot of the Eiffel Tower in the background?
Yes. Proof of location.
Okay, thank you.
Okay, so you couldn't hear anything?
I still can't hear you. Mark, over to you. So what we're announcing today is that the LXOY bridge contracts are live, and so this is like the very first step toward this aggregation layer vision. But there's also a really cool primitive that's being exposed with these contracts. It's called bridge and call, and it enables really cool cross-chain interactions across L2s in the Polygon ecosystem. Could you just describe? I believe we lost Mark. Could you just describe?
Take that one.
Just, Brendan, in the while, let me just point a comment because I think it's important for this. Just for this, I want to go back in 2015, at the beginning of Ethereum, when there was not this division between data availability and execution layer. Was exactly the same, and we're talking about sharding, but sharding was like a kind of mix of roll up with data availability because it was everything together. Okay, and at that point, we already knew this thesis that that individual blockchain will not scale, and we will need many shards. We will need many execution environments or many shards by the time. And I remember the work done by the Ethereum Foundation by the time. I remember some Vitalik's talks talking about composability, talking about asynchronous calls between shards or between data availability. This aggregation layer actually is the evolution of that time. I mean, actually, we are building that part. Of course, here we have the distinction of data availability. We have the ZK. We have much more big advantages. For example, by the time the shards had to be very homogeneous at some point. Here with ZK, we can have we can give chains much more sovereign on each of the individual chains. But all the tech of this composability between chains of calls, and this refers to this this message and call. But we can even talk about further about these synchronous calls or even atomic transactions. All these what of interconnecting chains. And this is the beginning of this era. Right now we start having different chains connected together, and actually is when this I think that today the historical part of today is that today it's possible that all that thing that was kind of theoretical today is start being possible, and all these interchain or layer 2 communication composability will start happen, and it's definitively possible. And here we have a huge space to grow and to build on that. If you want taking the simuls, if we have processors, one thing is doing a fast processor, which is a chain, and now it's going to have a multi-core processor. We have this idea of multi-core processors, and then of course the communication between processors and all that becomes a lot of importance. So this is very much where we are from the technology perspective in the historical manner, in the historical point.
Yeah, I think that's a really good point. I think one way to look at this is we get all of the nice guarantees of sharding, where we have asynchronous and synchronous cross-chain transactions. We have low latency. We have really nice trust guarantees. But fundamentally, the requirements and restrictions of sharding are not imposed on chains. We can have a heterogeneous environment where chains can coordinate with shared sequencers or relays or builders, but we have this fundamental guarantee of safety and asset fungibility that's guaranteed by ZK. And so it's a permissionless environment rather than one that's very sort of centrally managed and monolithic. And I think that's a really powerful vision because it allows so many different participants to come together to build this ecosystem. And so I think it's really exciting. I think a lot of people are right to be skeptical of sharding, but I think this is a fundamentally different vision that preserves the same guarantees and has some really nice properties in terms of who the participants are, who's building it, and how it comes together. But Mark, before you were bridged to another stream involuntarily, we were talking about bridge and call. So if you could just go into
before Mark says something, can you hear me now? Not only I was sitting in open, it started raining. It started raining also. So that's the first thing. And second thing is, Brandon, you said that you couldn't hear a word, and Mihalo spoke after me, and he said, "I second what Steve said."
Yeah.
Because
Mihailo.
I can feel what you're saying.
Mihailo's answer is very good, but Mark, so maybe you could go into like what bridge and call is, what behaviors and functionalities it exposes, and we can kind of go from there.
Yeah, and I think it's worth kind of take a step back, right, and talk like this first component, like the LXLY bridge, this unified bridge, like what does it mean, right? And like for now, right, what it means is like relatively slow, relatively expensive, like transactions that still like hit kind of Ethereum, right? And that's like not what the ag layer in its end vision is at all. But what we thought was there is actually a way that actually uses this unified bridge in a way that is going to create an amazing experience for like developers and users in terms of a unique feature. And this is where bridge and call comes into play, right? And so if you think of like your typical experience right now when you bridge onto an L2, you submit a transaction to actually bridge. Once you get and you've actually like bridged across, you then submit a transaction on whatever application that you want to use, and you use that application. And frankly, if you wanted to then leave that L2 and go to another one, you would bridge back to Ethereum and then bridge over and then start using an application again. What bridge and call allows you to do is in one transaction, bridge to an L2 that is connected to this unified bridge. That is the first component of the ag layer. And once you've done that in that same transaction, you could, let's use an example, you could take ETH that you just bridged and you could exchange it for Matic. In that exact same transaction, you could also take that Matic onto another chain and exchange that for a skin in a game and purchase a skin in a game. And so that is something that can all be done in one transaction with bridge and call that otherwise would probably take 4 or 5 separate transactions today. And that is all because of both this kind of unified bridge and the bridge and call function. And it kind of gives you just this little bit of insight into what the ag layer might look like from a reduction of transactions perspective and cross-chain transactions. What it misses is that whole low latency feel and like one kind of unified experience, which is what's going to come in kind of the coming months.
Yeah, that makes sense. I think the way that I describe it often is like right now in a multi-chain ecosystem, you're sort of forced to choose between deploying your application or your NFT or your game on the same chain where there's liquidity, or trying to deploy it elsewhere and like actually bootstrap liquidity on that chain, trying to like bootstrap an NFT marketplace or an AMM and that's actually really difficult to do. And it's something that I think is unnecessary for builders. And so like part of what makes this vision really powerful, in my opinion, is the fact that like an NFT, like you said, a game that's selling skins or an NFT collection or a DeFi primitive can deploy into the Polygon ecosystem and instantly access the liquidity that already exists and the shared state and the users that already exist in the ecosystem. And so like we're moving out of this mode where chains need to like play games and engage liquidity mining incentives to build liquidity on their chains. Like as a developer, you can directly focus on adding economic value in the form of a game or a DeFi primitive or an NFT collection. And you don't have to worry about bootstrapping liquidity. And so I think that this is like sort of a step change for the developer and the chain builder experience. And I think it's, I'm very biased, but I think it's really exciting. And so
on one of the key things there, Brendan, right? Which is like the idea that like you as a developer actually get to focus on like what it is that you're here to do and what you're good at. And you can focus on like, how do I actually just create the best user experience possible? Not how do I have to worry about like attracting liquidity and attracting like all of these different pieces of infrastructure that you might need around that liquidity, you're now like, I'm just going to build, for example, the best game possible. And then I'm going to abstract as much away from that user as possible. And that's where I'm going to spend my time and energy. And that is much better for the developers who actually want to develop and don't need to worry about it. And it trickles down to the end users in a very meaningful way because they're going to end up getting a better experience as a result of that.
Yeah, exactly. And
Yeah.
I think the other half of this, and here, just give me 1 sec, Sandeep. I'm segueing it into a question for you and Milo. Like the other part of this is like chains aren't giving up anything to participate in this vision. Like there are no restrictions on how you do sequencing, on how like what your token is for staking or for gas or for governance. Like there's no revenue share that's imposed on chains, and so this is fundamentally like an open and permissionless vision that's not a rent-seeking one. And so I think like Mihailo and Sandeep, when you think about like building the value layer of the internet and what that looks like and why we aren't focused on restricting how chains behave in this ecosystem, like why do you think that that's powerful? What's sort of the benefit of that?
Sandeep, do you want to start?
So before we go,
and I think his internet access was cut off.
Yeah, Mihailo, to you.
Let me take it, and he will definitely rejoin. Yeah, so it's a very transformative approach. That approach of unified liquidity, first of all, is, I would say, transformative both for Web3 or DeFi, to be more specific, standards, and traditional finance standards. So we have a completely new primitive, something completely new. The opportunity to leverage other chains, other application, other projects liquidity, right? It's a completely kind of new concept. And as you said, currently in Web3 we have this multiple layer twos competing for finite basically amount of capital, having to employ different kind of incentives and whatnot to attract liquidity, and liquidity by default ends up being fragmented, right? Here we have a completely different paradigm where chains are working with each other instead of against each other. So it's a proper paradigm shift, right? And as I said, both for and for traditional finance. So it's really exciting to see how that will play out and how projects will leverage that, and what's going to come out of that. That being said, to answer your question, we have understood, first of all, as you know very well, and as a lot of work has been invested on the technical side of things, designing the egg layer and the cryptography and how to make the whole thing efficient and scalable enough and all of that. But we have also, as you guys know, we have put a lot of thinking into how to really make this appealing or attractive to everyone to join. So we understood very early, I would say, also from that kind of business viewpoint, that this really has to be a public good. This really has to be a non-extractive service, non-extractive basically layer that is just going to bring benefits and bring value to all the chains that decide to participate, and not extract value, not limit sovereignty, not impose ideally any type of restrictions that you have to use this token or that token or whatever. You're completely free to do whatever you want to do in your ecosystem. There's just only this added benefit of shared liquidity, seamless interoperability with the entire ecosystem. So it's pretty exciting. And I would again say, of course, we are biased, but I think we have done a good work defining and designing the egg layer in a sense that it's really a public good and really a clear value add for every chain that decides to participate without extracting anything from them or limiting their sovereignty or anything like that. Yeah, over to you, Sam.
Absolutely, the sovereignty. Brendan, can you hear me clearly? By the way, yeah. So sovereignty basically has always been a very important element of that. And a testament to that is that you might have seen people who are active in the Polygon community, that even layer ones, which are like near blockchain, and then Canto and many other ecosystems like now, which are completely separate, they're not even layer 2, they also want to join the ag layer. And I really loved Vitalik's recent post regarding make Ethereum cypherpunk again. And in that one, he mentioned that build tools, not empires, right? And I think like ag layer is actually you know in its own inspiration is like that. Like we want to build a tool, a layer which everybody can use. It doesn't kind of restrict anybody, holds anybody. It just provides a great service and benefits. So if people want to use it on their own accord, they can use it. They are not like locked into anything or things like that. Like we don't want to do that. And then because it's a great service and there are so many advantages like interoperability and shared liquidity and all that, people would work over there. Another big advantage which I wanted to say, what Mark was also mentioning, bridge and call. Like many of the small features for the developers, let's say on ramping, right? In like how chains can work with each other. Like if one chain solves on ramping, then you can that on ramping solution, if they have a very kind of robust on ramping solution, that can be used by every other chain in the connected in the ag layer, right? So you can just do a bridge and call on ramp and come there. One good chain solves withdrawal and deposits from an exchange, especially the withdrawals. All exchanges, all chains can get withdrawals integrated using bridge and call from an exchange and all that. So like as Mihalo was saying, that this is like one architecture which also allows all the chains to work with each other. Anybody solves one problem, whether it's for liquidity, exchange integrations, on ramping, and so many other things, everybody else gets benefited also with that.
And fortunately, we have one of the largest exchanges in the world that's launching a CDK chain in OKX. And so I think that vision is something that's like very immediate and accessible. Jordi, I apologize that we've not gotten to you as much, but maybe as one of the last questions, you could talk a little bit about why this vision is enabled with ZK. Like you alluded to it a little bit earlier in your talk, but maybe just like the magic of ZK and why that's what's enabling this technology to exist.
The full point at the end is the ZK gives this immediateness. I mean, you can prove something with a single proof, and you don't need any interaction. I mean, the ZK is this non-interactive part. I mean, you prove something, and that's there. You don't need to wait, and here you avoid all kind of gaming. I mean, of collaterals, gamings, going back and forth, and it gives you instant, or if you want, the time it takes to generate the proof, but which is every time, by the way, every time it's faster and faster. Okay, so this is what gives you the immediateness. Okay, and this, when we are talking about, we're talking about the shared liquidity, but the shared liquidity, when you have many chains, means that you need this immediateness. I mean, you go to one chain, you do execute something there, you go back, and this immediateness is what ZK can give you, because I mean, you prove, you are there. You prove, it's like a clock. You prove and you go, and this is the importance, the big importance of this tech. Actually, you could do that in, let's say, on chain, but would be not practical, because meaning that executing things in the consensus layer is with doing something in Solidity. You could build that, but consensus should execute so many pieces of code that makes it not practical. In ZK, you can compute that aside, you prove that aside, and in the consensus, you just give the proof, and the proof moves forward. And this is what enables everything. I mean, the big secret of this aggregation and because this is possible, is because this ZK.
That's awesome. So I think that's a good place to end this panel. Thanks to everyone, and yeah, let's over to Hudson.
Thank you so much, Brendan. Everybody, thank you so much for coming here and speaking on all this cool technology that's being built and some of the applications. We're going to move on to the next panel now. So if you are not on the next panel, I'm going to remove you from the stage. I feel very powerful right now, just being able to remove everybody who is responsible for signing my paychecks. All right, so we're going to go ahead and get to the next panel here. We have some great guests, and I'm going to try to add people. Let's see. Add to stage. Ooh, okay, I still have the power. And let's see. Oh, there we go. So, Bobbin, why are you the Grim Reaper?
It's actually the character from a video game. So like this is his avatar. I'm just using it. But it does look, now that you say it, it does look like a Grim Reaper a little bit.
True. Okay, so this talk is going to be on Plonky 3, Type 1 provers, and Miden. We have some people from outside of Polygon Labs here that we're so excited to bring in to be in this discussion. We have Uma Roy from Succinct. We have Eli Ben Sasson from Starkware, Bobbin Threadbare from Polygon Miden, Daniel Lubarov from Polygon Zero, and Brendan Farmer from Polygon Zero. We're not letting Brendan leave today, apparently. They are trapped in the stream. So we're going to go ahead and get started on that. Thank you all.
Hey everyone, I think I'm also moderating this this panel, but
yeah, Brendan, you don't get to stop moderating too. I
don't really have anything to contribute myself compared to everyone who's on the panel, so I think moderating is probably the right role for me. But yeah, just really happy to welcome everyone, especially Ellie and Uma, who have both had huge, monumental announcements and developments over the last few weeks that we can get to. But maybe Ellie, we can start with you. Starkware and Polygon announced something that was sort of unusual for the space, because we are nominally competitors, and we have a very bitter and like intense rivalry, I think is a fair characterization. But we actually collaborated and came together in a really, really nice way to push the underlying math and technology forward through what's called Circle Starks. And so maybe you can just give your perspective on collaborating with others in the space and what this advance means for the technology.
Yeah, so thank you, Brendan. Indeed, we are competitors. I don't know if bitter competitors or something is the words I would use to describe, but we are competitors. And but we also collaborate, especially when it comes to math and science. And earlier this week, a very exciting math white paper came out, co-authored by Ulrich Habok from your team, from Polygon Zero, and David Levitt and Shahal Papini from Starkware, which could arguably lead to the next generation of super fast provers. The main thing there is that it allows to do a lot of the needed arithmetic to get Starks, which are the most scalable, fastest proving systems, also the safest ones, to get them to work pretty pleasantly over a specific 32-bit field known as the Mersenne prime, which has a lot of beautiful properties. So it's a very exciting piece of math, and it has some very elegant things, such as use of the good old circle that we all know from, I guess, kindergarten, right? That shape thing, but has also a lot of like very deep mathematical gems in it, and was a pleasure to see the very smart folks from both teams work on it.
Yeah, I think it was a really exciting collaboration for us, because obviously your team is well known as the pioneers of obviously Starks and a lot of the technology that we use at Polygon, and so it was really cool to be able to contribute. Obviously, you guys invented Starks and this technique called ECFFT, and so it was really nice to be able to sort of do our little part in furthering the research So
Well, it wasn't so little a part, but it was.
well,
And yeah, it was a pretty big part. So, anyways, like beautiful collaboration, and yeah, hopefully this will be the standard for next generation start provers.
cool.
A lot more to come there.
And I think this is not the first time we're collaborating, right? Or at least there was another paper that the log-up GKR paper that also was Polygon
Right.
Zero and Starkware collaborated together. So it's really cool to see it continue over time.
Yes.
Yeah, that's a good point. And then Uma, while we're on the topic of open source software and contributions, Succinct obviously released SP1, which is a really performant ZKVM that I think has a lot of people in the space really excited. To draw some connection to Polygon, SP1 leverages Plonky 3, which is a proving system library. And I'm just curious what your perspective is on collaboration and developing open source software and sort of like how we can build public goods both at the proving system level and at something like a ZKVM.
Yeah, thanks, Brendan. Yeah, as you mentioned, so SP1 is this general purpose ZKVM that lets people like write Rust, and then you can kind of get proofs. And yeah, it's built on top of Plonky 3, which Daniel and you and other people on the Polygon Zero team have been doing an amazing job with. We were big users also of Plonky 2, which was kind of like the previous iteration before Plonky 3. And Plonky 3 has been really awesome to use. I think one thing that's really nice about open source is, for example, the Circle Stark work, from my understanding, will be integrated into Plonky 3. And then that will help make things like SP1 or other projects built on top of Plonky 3 automatically faster without us having to with us being able to take advantage of it with like a few configuration changes and things like that. We've also contributed back upstream to Plonky 3 in some cases, I think helping out with the verifier, things like that. So that's also been really fun to collaborate with Daniel and like other people at Polygon Zero. So yeah, overall, I think we're really big fans of open source because the progress compounds and like helps make all the projects in using that technology better. So that's been like really awesome to see.
Awesome. Well, I think that's a good segue to Daniel. Could you talk a little bit about Plonky 3, where you see it going, what you see as the future direction for proving system development?
Yeah, definitely. So I'd say there were a couple motivations for Plonky 3. When we look back at Plonky 2, it was a nice library that's easy to use, but it had certain limitations. It had it didn't have much flexibility. It basically did things one way, and that was it. So it used Plonk-based circuits or simple Starks, and it used, for example, Poseidon as the hash, and that was pretty baked in. It always used a Fry-based polynomial commitment scheme, and yeah, it just didn't have too much flexibility. So as we started learning about new techniques that we wanted to experiment with, we couldn't really integrate them easily into Plonky 2. So Plonky 3 is much more modular. We have all of these abstractions for things like polynomial commitment schemes, low degree tests, a sort of vector commitment scheme type primitive, and so forth. So we can implement not just kind of standard Starks, but also more exotic ideas. For example, there was the idea of kind of taking Starks and then replacing Merkle trees with a RSA based vector commitment. So I'm not sure if that's necessarily a very useful option, but it just allows us to experiment with things like that. I think the other really nice thing about Plonky 3 is it has more powerful batching support. So in Plonky 2, we built this ZK-EVM on top of Plonky 2, and it really involved several Starks that get connected together. And with the way we approached that in Plonky 2, each Stark would basically get its own Merkle tree, and its own Fry instance. So it was nice and simple, but as we added more Starks to this system, we would just have more overhead from all of these different Merkle authentication paths that couldn't reuse any common nodes and these separate Fry instances. And in Plunky 3, we just allow all of that to be combined into one big Merkle tree and one Fry instance, even if the lengths don't match.
Oh, awesome. And then Bobbin, last but not least, Polygon Miden. This is going to be a very big year for Polygon Miden. Maybe you could give us a little bit of a preview of what's to come, and then how you think about taking sort of underlying R&D advancements like happened with CircleStark and implementations like Plunky 3, and kind of incorporating those into the Miden roadmap.
Yeah, definitely. So I'm personally very excited about Plunky 3 as well. Right now, just to state, we're not yet using Plunky 3, but I'm very much looking toward migrating Miden to use Plunky 3 because Daniel mentioned a few advancements, but I think one of the things I would like to highlight is that what it allows this different batching, what it allows you to do is to have different start tables or execution traces of different lengths and combine them in a much more efficient way. And you only pay for what you need. So, for example, in Miden, we don't currently do that. You kind of have a single table and or a single execution trace, and you kind of pay for the longest poll. But with this new technique, we would be able to kind of make it even more efficient because expensive things were not expensive, but the long poll can be in its own execution trace table, and you can then combine them together. So this is very exciting. In terms of overall roadmap for Miden, for now, we're focusing less on the proving system stuff, just because we're trying to get the actual rollup up and running. I think we're at the point where we have our DevNet kind of running already. We have a node, and over the next couple of months, we'll make this public so that people can experiment with that. And the idea is to get to mainnet later this year, so that we can actually have people use Miden in a more kind of real world scenario, so that we can also learn from kind of use cases that people want to use Miden for. At this point, we have a few ideas. I think last week we announced this Pioneers program where they will have a few projects building on Miden, trying to use specifically some of the things that Miden allows, like local proving and things like that. And I think thinking into the future right now, in my mind, if you want to generate proofs on the server side, we're very close to the point where with things like Plunky 3, you will get to a point where the proof costs are fairly small. Miden actually wants to do it on the client side as well, and this is where further advancements with Plunky 3 and maybe even beyond would be very interesting, because on the client side, you are quite a bit more constrained. Frequently, you want to run on a laptop or even a smartphone. And taking this is the the next frontier in my mind, where we've got to a point where on the server side proofs are almost negligible. We still probably have a couple more years to go until we get to a point where the proof costs are truly negligible, but on the client side it may take a bit longer.
Mm-hmm. Yeah, that makes sense. I think just to step back for context, if people are confused about Polygon has zkVM and CDK and Miden and the Ag layer, Polygon Miden chains will be, at least the way that I think about them, will sort of be an option for CDK. And so they'll sort of be units and execution environments in this broader ecosystem that's connected by the Ag layer. And so I think that's a really, really exciting thing, because it means that you can have these amazing, innovative features on the execution environment side that are brought by Miden, and those can interoperate with your zkVM chains and other chains in the Ag layer environment. So I think that's a really cool future direction, because we ultimately want things like privacy and client-side proving and all the features that are offered by Miden. So
yeah, this is a super cool thing where you can have EVM-based chains and non-EVM-based chains all kind of come together in a single system.
Absolutely. So Ellie, I'd like to go back to you. I think as someone who's been maybe more than anyone else in the Validity rollup space, a core contributor and pioneer of the underlying technology. I'm really curious, while we have you here, where you see the technology going from the R&D side. Like, are we just going to see sort of steadily increasing efficiency and reducing cost for proof generation? Are we going to see more of a switch to hardware? Like, where will the advancements come from in your view, and sort of how close are we?
So I think first we'll just see optimizations on existing hardware, CPUs and GPUs, and I think in this respect, both things like RISC-0 working with the Baby Bear Prime 32-bit and the new proof systems, Plunky 3 and stuff we're working on that will use Circle Stark will probably be the next standard generation. Let's call it 32-bit primes. And first of all, we'll just see it optimized on the CPUs and hardware. And there's a long way to go there and make things just a lot more efficient. That's probably the next step. Further down the line, I think that in terms of like the math, probably people will continue to explore also binary fields and maybe smaller fields and more exotic curves, than the circle and elliptic curves, stuff like that. But also, once you're down to things like 32-bit primes, this is already a very good point to think about hardware. It's just that for hardware, you want to know that there's going to be massive demand, in the tens to hundreds of thousands of computers that need to run it all the time at very high efficiency. And yeah, maybe now we're starting, now or in a year, maybe we'll start to see not yet the demand, but getting ready for the demand. And the last thing that I'll say is that probably we'll just see a lot more usage of mostly, I think, Starks, but like in general, proving systems to do things like layer 3s and layer 4s, client-side proving, maybe even a little bit. We're not yet. I mean, privacy will come at some point. It's not that it's not important. Just the UX aspects of doing privacy right make it something that will come later. So summarizing, I think the next generation is probably going to be something around 32-bit fields, probably primes, but maybe also, which means that it's really, really there's a very good fit with existing hardware on CPUs and GPUs. And this will open the door to a lot more client-side and just, end user usage at much higher speeds. And then hardware optimized things, maybe, we're still, let's say, 1 year out from starting to plan them, or maybe 2 years out. Yeah. But I'm very, very optimistic about the usage of proving systems to boost integrity and expand the scale of blockchains.
No pun intended with the use of optimistic there, obviously.
No pun intended. I'm very optimistic about validity rollups. I'm even optimistic about optimistic rollups ending up being validity rollups, and I think they even say that that's their plan. It really is there's just a lot more. I mean, validity rollups and especially Starks, post-quantum secure, no trusted setup, very high efficiency. They really are, to the best of my knowledge, the end game for scaling integrity. So yeah.
Yeah, I mean, certainly in Polygon's view as well, because we use them fundamentally in all of our rollups.
I need to jump off, but great to see all of you.
Yeah, likewise. All right. Well, I guess, Uma, back to you. So maybe you could, I could ask a version of the same question, but instead of for the underlying proving systems, we could talk about ZKVMs. And so I'm really curious what you see as kind of the short-term and medium-term roadmap for ZKVMs. I think to give people a little bit of context, a general purpose ZKVM, like you said, allows anyone to take Rust code, and they can just compile it to run. They don't have to write circuits or sort of ZK specific languages. And I think it's an interesting thing because like when we were doing the ZKVM, I thought to myself, and I sort of said this, that like it's a mistake to ever bet against the development of technology. Like this technology is progressing so quickly, and like the number of things that are possible with ZK is expanding so rapidly, and it's a mistake to be sort of pessimistic about it. And I have this like sort of weird feeling looking at general purpose ZKVMs where I expected that they would be a little bit further off, and that it would take a little bit longer to achieve the performance that like SP1 has achieved. And so I think it's, it's sort of an interesting thing where the technology is developing really quickly. And I think that there's this sense where looking at something like SP1, it's not the finished product. Like it's something that is like at the early stage, and there's a lot of room to optimize and to make it faster. And so maybe you could talk a little bit about that process and how you see it.
Yeah, I think I totally agree with your sentiment that general purpose ZKVMs have progressed a lot faster than maybe a lot of us thought. I think even personally, our team had written a lot of circuits for a lot of different bridging use cases. And while we were developing SP1, which leverages Daniel and the rest of the Polygon Zero's amazing work on Plonky 3, and as you guys have been mentioning, the multi-table stuff is a lot more efficient and a lot faster. So we were using that and building it. And SP1 also has some like a pre-compile system that makes it, that is a lot of the performance gains. I was even personally surprised at how fast it was. There's like some anecdotes from people on our team trying it out for use cases like a Tendermint-like client. And actually like our performance with SP1 is within striking distance. I would say maybe a factor of 2 or 3 off from our circuits, which were, took months to build and develop. And then with the SP1, you can just write it in an afternoon. And yeah, Brendan, as you mentioned, this is still like very early days. I think there's a lot of even really simple optimizations that we could do or other people can do. I know the Mersenne stuff going into Plonky 3 is going to be another speed up. And one interesting thing is we recently released SP1 Ref, which is kind of an implementation of a ZK EVM using something like SP1. And we found that the performance was maybe within a factor of 5, certainly within an order of magnitude of the Plonky 2 ZK EVM. And you guys did like such an amazing job with that. And I think it was like a really, really big endeavor. I've seen the code. There's a lot of like handwritten assembly. There's just a lot of complicated moving pieces. And
don't for our own sanity, don't tell us how quickly you were able to write the rest. Okay, do it. But
yeah, it was so 2 people on our team spent like the weekend doing it. And it was like 2,000 lines, of very maintainable, reusable Rust code. It took a weekend, and yeah, it was within like, I think, an order of magnitude of performance. And we haven't even started optimizing a lot of things. And I think there's a lot of room to use like more optimized primitives and, get that performance even further down. So yeah, that's really exciting because I think this is like hopefully the thing that will let ZK just be more used everywhere, because now you don't have to worry about like if you're a developer using ZK, you can just like write your Rust code and then know all the stuff underneath is going to get faster and faster. You don't have to worry that like, oh, I spent so much time writing all these circuits and then, oh, it's going to be obsolete because there will be like this new proof system. Like Rust kind of being the like normal code and Rust being the universal interface is something I'm like really excited about. And yeah, hopefully just embed ZK into like every single application, like every single rollup, every single bridge, every single Oracle, every single coprocessor, hopefully ends up using ZK like in this form.
Yeah, I actually agree. I do think that there is like for our type 1, I think that there's like a lot of low-hanging fruit for optimization. And so I can imagine that it might be the case for like the next like year or two that, a handwritten ZKVM just kind of offers like really nice performance. But like certainly it's our view that in medium term, even like this approach of compiling to a zkVM makes total sense. And I think that's been a lot of our motivation with pushing on Plonky 3 and even contributing to projects like Valida. Like we view this as like really improving our ability to execute, like you said, really, really quickly. And I think like developer velocity can trump like performance, especially if like the performance margins in absolute terms are like really pretty small. And so I think it's like really, really exciting work.
Yeah, totally.
But yeah, Daniel, maybe you can talk a little bit about your views on like the future direction of the Polygon ZK work and you know, zkVMs, Plonky 3, proving systems, like how you see the world sort of developing in the near term.
Yeah, I definitely agree about these new generation zkVMs such as RISC-0, Valida, and SP1. I think that's going to be the future for a lot of ZK projects, just because they're so easy to use, and they, you know, out of the box, the performance might not be as good as a handwritten circuit, but you can kind of selectively pick the things that actually need to be optimized. So I think that approach makes a lot of sense, and yeah, really looking forward to that feature. And also, just going back to performance for a bit, I think the kind of the reason that we've seen such massive strides in performance of ZK software is, you know, I think there's just this cumulative effect from improvements on several different layers. So if there's new academic improvements like the recent Circle Start paper that just came out, but at the same time, there's low-level optimizations. For example, some of our teammates are working on speeding up arithmetic hashes and that sort of thing. And at the same time, there's work on better optimizations. So for example, something like SP1 uses kind of a newer memory argument and just a lot of improvements compared to some of the older zkVMs. And at the same time, Moore's law is still chugging along as well. So there's kind of improvements on these like 4 or 5 different layers. That's not even considering potential acceleration from GPUs or ASICs, which is a whole other layer. And it just really compounds and adds up to this massive exponential speed up.
Awesome. Yeah, Bob, and maybe we can continue on that theme. I know that you're very interested in hardware and have been leading a lot of our projects to look at, or at least heavily involved in our projects to look at GPUs and FPGAs. Like, where do you see the maturity of those of the hardware approaches sort of being right now?
Yeah, I think I probably would agree largely with what Ellie said. Like, it maybe is like, but maybe a bit even more optimistic than that, because I think you know, we, especially around the Starks, like we're at the point where I think we can start thinking about hardware. I think maybe a couple of years ago it was too early to start thinking about hardware optimization, but now I think it's maybe the right time, or certainly within the next year is the right time in my mind to kind of think how hardware will play into accelerating this, because I do think like the next you know, 10 to 100x improvement could come from hardware rather than further improvements on academics. I mean, there's still a ton of improvements that they can do with existing system and optimize them and things like that. But I think we're getting close to the boundary, and you know, obviously nobody has a crystal ball, so maybe somebody else will come up with something that is like massively simpler and easier. But in my mind, this is more kind of like a black swan type of event where, you know, it could happen, but probability is probably fairly low. But if we kind of try to think of where is the next massive improvement will come from, beyond what we have now, kind of in academics world and, you know, some software implementations, is in my mind, you know, going to, I'm not even sure if it will be directly to GPUs or it will go like it will be to GPUs or going directly to ASICs. So there is an argument to be made that if you care about costs primarily, like you probably want to stick with CPUs, because GPUs, at least in the in a cloud environment, it's very difficult to get like the right instance where the costs make sense if you're doing the GPUs. But I'm actually personally very excited about like some of the newer ASICs that are coming or being designed or should come to the market in the next year or so, and we'll see how they can be leveraged to improve proving speeds. I think I personally want to like start looking at them even like in the next few months or something like that, and then it will take a while for them to get into production, probably at least a year, maybe 2 years, maybe even more. Who knows? Like there are other things, but I think with like recent improvements, things are stabilizing more. We know it's going to be probably around like 32-bit primes. There could be some still usage for like Goldilocks primes and things like that, but mostly it's kind of like converging on for Starks at least around the smaller primes. Now, there is something to be said about FPGA. There is a different way, like I think Binius and other proving systems that rely on other like binary fields. There may be more amenable to FPGA-based implementations. Maybe it's easier to do it. So like it would be interesting, but like I do think this is where like the next big frontier.
Yeah, I would agree. I'm also very excited about binary fields. I think the Binius work from Olvatana is super cool. So we're running low on time, and we've been talking a lot about optimization and the future and bringing costs down. But I want to like bring us a step back, and I think that a very popular narrative, especially from some projects that are working on optimistic rollups, is ZK Tech is like a little too far out. The cost isn't really where we want it to be. It's like it requires like some more development. And so I want to poll each of you as to whether or not you think that that's true, and whether you think that ZK technology is ready now and is sort of cost competitive and offers a better experience than the optimistic side. At the risk of like maybe this being a little bit too spicy, but Uma, we can start with you. Is ZK Tech ready now?
Yeah, I think all of us on this panel probably have a very similar opinion. But especially with things like seeing your guys' type 1 ZK EVM having a proving cost of $0.002 or 0.002 cents per transaction. Currently rollups today pay 10 to 20 cents to Ethereum for call data for data availability. What's another fraction of a penny for ZK? And you get all these benefits, like the withdrawal window can go down from 7 days to like a couple hours or however long you want to post a ZK proof. You don't have to worry about all this complicated interoperability stuff. Like it just kind of works. A lot of optimistic rollups still don't have working fraud proofs in production, and you can just like skip those steps and just use like ZK. Something I like to kind of like think about and tell people is ZK is in some ways actually very simple, because it is this simple black box primitive where you say, hey, I have this function, and then I give you a proof, and then like that state transition function happened properly. Like there's no interactive game, there's none of this stuff. And I think like the truth of ZK is like very simple. Once you kind of have like the proving system stuff out of the way and everything abstracted down. So I think it's like ready now, and like it is kind of surprising even that more people aren't like transitioning over to it, because I think it could help solve a lot of problems with a lot of their stacks.
Awesome. I think that's a really good way to put it. And we're super short on time. Daniel, ZK Tech, here now, here today.
I'd say definitely yes for proving blockchains. It's more or less a solved problem now. There are always a few more challenges. Like there's a team that I've been talking to that's proving LLM inference, and that's still a hard problem. But yeah, for proving blockchain execution, it's I think we're already there.
Awesome. Bobbin?
So I would say two things. First, is ZK Tech ready for you? And it depends on one factor. Right now, it depends on one factor. Do you have a like ZK talent in-house that could develop this? At this point, I would say it is ready for you if you have the ZK talent. But with work with like Uma and RiskZero and others are doing, maybe like in a year or so, it will be at the point where it is ready, even if you don't have a ZK talent, and that's where we're all trying to get to.
Yeah, that's a great way to put it. And I would say, just to note, to be very, very spicy, in order to have parity in safety with zero knowledge proofs, with ZK rollups, optimistic rollups need permissionless fraud proofs. And to my knowledge, no one has permissionless fraud proofs, but we do have ZK proofs. So kind of leave on that note. But yeah, thank you all very much for participating, and really enjoyed it. Hudson, over to you.
Thank you so much. Spicy Brendan is our favorite Brendan of all the editions of Brendan. Thank you all so much for joining us on this panel, and we're going to go ahead and move on to a video, I'm being told. It's short, but it's sweet, and let's go ahead and get that rolling. Wow, that was really, really cool. I need the audio from whatever they used for that. So next up, we're going to have a panel called the Path to Synchronous Composability. So what I'm going to do is use my ultimate stage powers to start bringing people up here. Some people would say I'm drunk with power. I would say that, oh, I put Bobbin in there. Nope, sorry, Bobbin, not this one. Someone would say I'm drunk with power. As it turns out, yes, I am, and no regrets on my end for that. All right, awesome. So we're going to go ahead and take the slides down. Thank you all for joining us today. I'll go ahead and just say everyone's name. Zaki is here. Brendan is yet again moderating. Ilya is from the Near Foundation. Sriram is Eigenlayer, and Ben is from Espresso. Oh, and I didn't even mention Zaki is Occlusion and like 19 other projects. So everyone, welcome, and we'll just take it away from Brendan.
I did not realize that I was moderating this one as well. If I was unqualified to moderate the last one, I am surely unqualified to moderate this one. But it's really, really nice to have so many people that know far more about asynchronous and synchronous composability than I do. And so I'm just really excited to speak with all of you. Maybe we could do a round of intros, starting with Sriram.
Hey everybody, I'm Sriram. I was formerly professor at the University of Washington, Seattle, and I run a project called Eigenlayer, which allows anybody to stake and use the security for arbitrary new protocols.
Awesome. And then Zaki probably needs no introduction, but can give one anyway.
Sure. Zaki, co-founder of Occlusion DeFi protocol called Sommelier. I've done some other things.
Cool. Ben?
Yeah, I'm Ben. I'm the CEO and co-founder of Espresso Systems. We're working on shared sequencing and base rollup solutions for sharing liquidity across chains. So this is a very relevant panel.
Cool. And then, last but not least, Ilya.
Hi, I'm Ilya, co-founder of Near. Near started as asynchronous sharded blockchain and now pioneering chain abstraction.
Awesome. So I think that's a good way or a good place to start. Maybe we could go through and each of you could just give your view on the necessity of synchronous composability. I think we'll have some like maybe differing views, but Ben, I know that Espresso is super focused on shared sequencing. One of the superpowers of shared sequencing is enabling synchronous composability in different forms. And so maybe you could just give your view on synchronous composability, whether it's required, and like what it provides.
Right. I mean, I think, and I think synchronous composability is, maybe the holy grail or far end of the composability spectrum. And there's also forms of composability that are not perfectly, what we might call synchronous composability, which are already useful. But in general, the value, I think that the value of Ethereum is the fact that it is one system, and the fact I think the value in any blockchain is its global scale. The fact that if you build an application and I build an application, these applications can talk to each other, and that's very much what distinguishes it at a user level from Web 2. I mean, of course, there's a security element as well, but in terms of the utility of Web 3, it's been the fact that it can get so many different people to trust one system where all these different applications are pluggable with each other. And so if we're trying to scale blockchains, we want to retain that utility. And synchronous composability is the holy grail of composability. The idea that a single transaction could do things in your application and my application that are all dependent on each other. It could move assets from one to another. We could do things like flash loans, etc. But there are also weaker forms of composability that are already very useful.
Okay. Maybe Saki, do you have a view?
I wanted to go do something first, which I would think we should try to define synchronous and asynchronous composability without assuming anyone knows what we're talking about. Maybe I'll give like a concrete example of these things. So synchronous composability is like anytime you let's say you've used Instadep. Instadep is a great example. Synchronous composability app. It has these things called zaps, and you can take a position move from, let's say, lending on Aave to I don't know, the eigenlayer deposit contract in one transaction, and it'll swap for you through Uniswap. And the whole thing will atomically succeed or fail, right? So you get this property of atomicity, and it's very familiar to every crypto user. You go, you do your transaction, you get the transaction ID, you plug it into Etherscan or another block explorer. It gives you maybe a comprehensible error message if it didn't go wrong, but this is your user experience. If you've used something like Squid Router or ibc.fun in the Cosmos ecosystem, you'll have the experience of async composability. So there's a set of transactions that get strung together. Maybe you don't have to do all of these transactions yourself. We've gotten better at that, but they could fail independently. You could start an IBC transaction, but it could time out in the middle, or there couldn't be enough liquidity, and your coins might not return to the blockchain you started out with, but they might end up on another blockchain. So this is the common experience of these things. Earlier work, I worked on a asynchronous composability system called IBC for several years. It's widely deployed. It moves billions of dollars. Then I worked on a multi-chain DeFi system called Sommelier, and I don't want to go into the details of it, but it does very sophisticated things. Our vaults are the biggest liquidity provider for wrap staked ETH today, and it's this complicated cross-chain system that does it. And at the time when we started building it, we could only have thought of building something like that on Ethereum synchronous. But just in the last week, we launched on multiple L2s with Sommelier. And then soon we're going to have vaults that actually share liquidity between L2s. And we thought when we started, we didn't know how to do this, but we're 2 years into having these things, to working on this project. And we were about a year into being in production. And as we've gotten more experience, we've actually learned how to deal with asynchrony pretty well. Now we have to cobble together these systems. Our cross-chain system has IBC, Axelar GMP, CCIP, and intents in it, which is kind of ridiculous. But that part of the process is more painful to us than asynchrony at this point.
That makes sense. Yeah. It's a good starting point with definitions. Sriram, how do you feel about synchronous composability?
Yeah, Zaki defines synchronous and asynchronous composability. I'm going to go down one more level and just define composability. The thing is, I think there are different, when we're thinking about composability, I just want to bring back one aspect, which is what is the trust model for composition? And there are many different trust models that one can think about when you're composing, which is using multiple systems together. And the weakest trust model, or the starting point of the trust model, would be something like, I have two domains and I want to kind of do actions on these domains, or two applications and I want to do actions on these two applications. Each of them, maybe they're living on a chain. So, and to compose this, now I'm using a third actor called a bridge, and the bridge is now helping me move information or assets across these two. In this model, now the trust is the worst of the sending domain, the receiving domain, and the bridge. And then you can go to one level, a trust minimized, which would be then say, oh, I don't have an intermediate actor, and IBC is like this, which Zaki and others pioneered. And IBC is like, oh, if both the domains are safe, then your transactions are safe, right? So you don't need to rely on a third actor. And so in this kind of like a composition, the trust assumption is that this might happen. So the trust assumptions on composition are in a separate dimension from synchronous or asynchronous composability. So I just want to kind of bring out this dimension here. And in something like IBC, you're basically trusting both the domains to be safe. And then when you compose across multiple apps, you may be taking trust assumptions across many different trust zones. So you are only as secure as the weakest of the trust zones that you're touching. Now, what is even more trust minimized than this is to have, if all of these different zones are identical, if they all depend on exactly the same trust assumption, then the weaker of all of them is still the same thing. And that happens when, for example, you have things like layer 2s. You have layer 2s on top of a common blockchain, then they all move together on a common underlying substrate, and they're all verified and validated together. And what this does is to provide trust minimized composition, or you could say trustless composition. Basically, all of them are correct or unvalidated, and there is no way for the systems to desynchronize. So normally when you think of like composing, you have this problem that these two zones, you can think of them as two trains kind of running in parallel tracks, these two chains moving along. And when one of them, on a bridge is basically like this like rigid thing connecting these two like moving trains, right? And what could happen is one of them desynchronizes, which means they fork, or something happens, then the rigid object connecting it can just break. So that's a kind of a mental model for the trust model of using a bridge to compose between these two. Something like layer 2s on top of a common substrate is basically you have a train, and inside that there are many like people sitting, or like many boxes, and all of them kind of move together. They cannot desynchronize. And so this is just a hierarchy of trust assumptions when we are thinking about composition. And I think this is a completely different axis than the time scale of composition, right? And the time scale of composition, Zaki already defined synchronous, which is actions happen simultaneously, atomically together, or don't. And this itself could require additional trust assumptions, right? So I will have atomic composition if ABCDEFG holds. So just, the temporal axis and the trust axis, two different axes that we need to think about when you're thinking about these systems.
Yeah, I think that's a really good way to put it. I mean, certainly it's how we see the ag layer, is like, how do we ensure safety and preserve, in some sense, this trust minimized property while massively reducing latency and creating the ability for atomicity. And so yeah, I mean, not to shield Polygon stuff, but that vision is possible in conjunction with things like shared sequencers, like what Ben's working on with relays and builders. And so but yeah, this panel is not about Polygon, it's about you guys. And so Ilya, how do you see, obviously, like Near is very focused on asynchrony, and I think that you, maybe more than anyone else, have seen sort of like the limitations and the pitfalls of synchrony and sharding and locking, and sort of like the cost that some of these systems or assumptions impose. And so it would be really good to get your view on asynchrony and synchrony and trust minimization.
Yeah, I think maybe a good way to describe it is kind of, if we take Ethereum, right? In Ethereum right now, every transaction stops the whole world. It's pretty much like when transaction arrives, everybody's like, okay, everybody stop. We're going to process this transaction. This is the most important thing. And then, okay, let's move to the next transaction, right? And, there's 100 gigabytes of state. All of that state is locked, even if this transaction processes and touches like one smart contract. Now, Solana introduced this idea that actually, if you mark up on your transaction which pieces of state you're going to be executing on, you can lock only that state, and then so you can, in theory, process in parallel a bunch of stuff. And there's like techniques how to do this on EVM now, but that kind of was the original idea. Is like, if you know what you're going to be touching, you can lock only that state, and then you can use the fact that you have lots of cores on your computer and process things in parallel. So you can still have, in a way, the same kind of level of composability, even though you have kind of parallel computing. Now, the challenge was that you still are limited by what one computer can do. However, kind of powerful computers are now, it's still kind of, okay, let's stop the world and process all the transactions that we can on one machine. And so kind of our assumption has always been, right, if we are bringing billions of users, there's no single computer that will be able to process that. There's no single computer that will be able to even store all of the state and transactions that are kind of needs to be processed. And kind of, the way this is usually dealt with is by parallelizing the execution, by parallelizing the state, and, it's called sharding. Now, that is naturally, requires some mechanism of, kind of figuring out how to process things in parallel and maintain consistency. And we have now like a spectrum of approaches, right? There's an approach of Cosmos, which is like, hey, let's just have like everything is an independent chain, and they're all kind of fully asynchronous, and there is a message passing protocol to synchronize kind of when you need to communicate. You have indeed rollups, which described, which is kind of like, we have like a base synchronization base, but they're still running in parallel and like firing in parallel. And because right now, at least, the current frameworks all have very different kind of approach to how proofs are settled, like the actual, like we have this kind of lots of like, oh, can I settle actually this there, or I need to wait 7 days, right? And so there's like few approaches like Agglayer and Fast Finality. We're working with Eigenlayer to actually synchronize that more and give you this like some framework there. And then the Near's approach, kind of from where we started, was, well, can we have kind of the same thing? Like if you have, every smart contract, every account actually has independent rollup, but we synchronize them every block. So we kind of communicate and synchronize every block. And so because of this, we can do message passing, we can do all of the things kind of embedded into the system itself. And you still have this asynchronicity from perspective of every independent account or contract. You send a message to somebody else, right? It's all like, because they are running on different computers. But now you have some guarantees about message delivery, consistency, and kind of all of these things. And so that's kind of the spectrum, right? And I mean, it's really cool to have all of these options, because there is like different cases when different of these options are needed. And in turn, you get like everybody's working on the trust minimization on the other side, right? Where like, you know, Cosmos has also, you know, how do we do shared security? Obviously, you know, Ethereum with rollups, but also with Aggregation. Like, how do we do shared security, kind of faster finalization? And then Near kind of provides it on the base layer. But I think the biggest benefit, though, coming back to what Ben mentioned, is like we can rely on using other applications without, like, you know, if you usually in Web 2 use something and it's built by two people in a garage with a dog, like you're probably not going to build $1 billion business on top of it. But in crypto, you can actually do that because you have this kind of trust minimization. You have, you know, kind of smart, you know, how the smart contract will execute and run. Now, there's a lot of caveats on all of this, right? You know, the upgradability, the kind of what is the trust mechanisms between in all of this. But I think that's the biggest benefit that we're getting in crypto. And so, like, for me, composability is the biggest benefit we have in crypto and in Web3. And we need to promote that, and then just give as many tools as possible to developers to really like connect these things together.
Yeah, I think that's a really nice way to put it. I'd like to change gears slightly. And you mentioned, Ilya, like sort of some of the instances in which synchronous composability imposes costs because you're sort of reliant on a single machine and you have to take locks. And one thing that Justin and Ben helped me understand and learn about is sort of this, I would say this new paradigm where we kind of apply proposer-builder separation to shared sequencing. Like my naive view of what shared sequencing was okay, we have some committee and they process all the transactions and they order them, and that's actually not really the vision for shared sequencing. It's we have some committee and they auction off slots to super professionalized, like high capacity builders. And so these builders can be running in data centers. They're not really constrained computationally, and they can actually coordinate synchronous composability across many different chains and domains. And so, Ben, I think you're sort of the best person to like dive into that vision and talk about sort of that view where we don't really give up decentralization, but we highly leverage centralization to provide synchronous composability.
Yeah, I think that you know, one way to think about it is that in any consensus protocol, like there's two parts, right? There's a proposer, which is acting, at least for a moment, as a very centralized entity. And it's the one that's like basically doing the execution for everything in this blockchain and creating a proposal. And then the security of the blockchain comes from the fact that you have testers, which are, you know, stamping their approval of what the proposer did. And this is going to ensure that the blockchain doesn't equivocate. So whatever was proposed doesn't get changed later. And in some cases, it's also doing verification, although one way to think of rollups is that they like massively distribute the process of creating the information that is needed to verify what was in a proposal. And that information doesn't need to be re-executed and verified by everyone. So with shared sequencing, we should think of it as, you know, just another mechanism for basically determining who is this proposer. I mean, even if you have rollups that are each running their own thing, if they each have a decentralized protocol, it could be the case that there is one proposer who just tries to be the proposer for all of these different rollups. And in so doing, it's able to create an economic surplus because it can do things that other proposers that are not coordinated wouldn't be able to do. And so a shared sequencing mechanism can be re-envisioned as a shared mechanism for, you know, in the most economically efficient way, determining who gets to be the proposer for producing and sort of coordinating between rollups in each slot. And this doesn't have to be fixed forever. It can be dynamic. And we can think of it as a marketplace whereby rollups are effectively selling their block space through this marketplace to bidders who are trying to become a shared proposer. Maybe not for all chains, but for a pair of chains. And so that's, yeah, I'll pause there, but that's sort of the way that I think about it.
Yeah, I think that's like a very compelling vision, because we can have like like I think in the world where we don't make usability trade-offs, or we don't sacrifice like the experience of using a single chain, even in this multi-chain ecosystem, like we need probably a decent amount of synchronous composability. And I think that this view is one where we can actually have that at scale without giving up things like security or decentralization. Obviously, I think that there are maybe some trade-offs, and maybe Zaki or Sriram can speak to those. But I think, like, for me personally, it's like a very cool view, and one that's like really complementary to what we're trying to achieve at Polygon.
I find this vision like very intriguing. Like it's very, very intriguing because the trade-off between like big, like large fat blockchains, like the sort of monolithic blockchain thesis, right? Is like, yes, you're going to go and do most TPS as fast as, but maybe the need for synchronous composability, or like the economic surplus of synchronous composability, like where is it that like it was just massively more capital efficient to be able to synchronously compose than it would have been to have to asynchronously compose these systems? Maybe those things are not routine. Maybe those things happen infrequently. Maybe, you know, someone trading NFTs over there and someone having a perp dex over here, like those things don't need to interoperate very often. And there's very reasonable, and you know, there'll be like a lending market and a spot dex, and like these things can be independent. And there's lots of opportunities, as I think we've seen a lot of experimentation in various ecosystems around like optimizing for these things, or we see a lot of perp dexes and Cosmos these days, and their need for synchronous composability is infrequent, if not non-existent. So the idea of having, you know, of getting to a world of this, like where you have these like where you have this marketplace for block space and you have this like ad hoc composability, it does seem very it does seem like a way of having our cake and eating it too. My only caveat of it is that like these systems tend to be very complex. They tend to be very complex relative to like sovereign asynchronously composable systems, or like sharded asynchronously composable systems. And I think like the biggest open question is whether or not that economic surplus is large enough to justify the technical investment needed to like bring this sort of ad hoc synchronous composability world to life.
Yeah, I think that's a fair characterization. I do, and I'd be curious what Ben and Sriram and Ilya think about this, but I do think that the nice thing about this vision is that it degrades sort of gracefully. Like if something goes wrong with the builder, or there's like some issue with the complexity inherent in the system, then I do think it sort of reverts back to functioning without synchronous composability. But I really like what you said about like monolithic chains, and the way that I sort of describe it or like to think about it is like Solana is a monolithic chain, not to pick on Solana, but on Solana you have like on-chain games that are contending for shared resources with like dexes and flash loans, and it does seem like there's like just this inefficiency that's inherent in that design, where like you like those games are like paying for synchronous composability in some sense when they truly don't have to, because they don't need to be like so closely located in the sort of composability space to DeFi primitives that like actually require composability and synchronous. But yeah, I on the question of like complexity and how this vision like holds up when things go wrong, maybe Sriram and then Ben or Ilya, I'd be curious about your views on this.
Yeah, I will stick to my dimension trust. So when we are thinking about synchronous composition in a system like what Ben just described, which is, you know, builders basically coming ad hoc and aggregating multiple block spaces and producing blocks simultaneously. So, you know, when we think about trust here, it's always the question is trust for whom? And to think about it from an end user point of view, let's say I want to make a transaction which is synchronous across 3 chains and atomic. And from my viewpoint, transactions should only fail if these 3 things happen together. Now, again, we can start seeing there is a nice trust spectrum here. The first kind of like a operating point here would be something like, or the builder makes a promise that they are going to make sure that these transactions all happen together, right? And this would be the first, most trust requiring type of atomic composition. Okay, I trust the builder. The builder promised me, like, they're going to do it. Okay. Then you can go like one level up and then say, no, actually the builder has already staked, for example, a certain amount of economic capital, made an assurance that if I ever break my promise, so they make actually credible commitments on chain using something like Eigenlayer, make a promise that I'm sticking to my promise and I won't break it. And if the amount of economic capital that is at stake is higher than the amount of economic value that can be extracted from breaking the promise, then you can assume that they'll be honest, and even if they're not, you can slash them and redistribute the money to the injured users. So that's another kind of level up on the trust assumptions. The highest grade of this trust assumption would be something like the ag layer that Polygon's building, which is now, when you're making commitments to the to each of these chains, I actually acquire a lock and submit a ZK proof that I've actually held. So it's basically just the same thing, which is credible commitments, where you make a credible commitment a priori. But the commitment is enforced cryptographically rather than cryptoeconomically, which is what something like Eigenlayer would do. And I think that kind of sets the kind of trust spectrum here, which is you have this zone, the different zones of operation, which may be different layer 2s, for example. And then what happens is that each of these come together on demand, ad hoc, to when there is the economic surplus that Zaki was pointing out. And they come together to make blocks, and it's justified because the cost of making these blocks actually together is worth it, right? For whatever other reason, because at that time there is enough interactions. The really nice thing, I think, from my point of view on this is that it is a much more bottom-up, design where you don't have to coordinate a priori. You can coordinate a posteriori. Like when the events to actually coordinate arise, you can actually coordinate them. But you should have made some kind of pre-arrangement on the coordination mechanism. Otherwise, you will not be able to coordinate post hoc. Just adding one more kind of dimension here, which is the near finality gadget, for example, that we are working together on. The idea there is, either with the in any of these methods, one of the things that you absolutely need is that when you make promises that these are the blocks that need to be built, you should not be able to build some other blocks, directly by bypassing that system. So you need a lock that, when you've sold the blocks that you're actually kind of building in this order, they actually get built in that order. And I think, there are different ways and different layers in which you can express it. And I think that's, with the nearest finality layer that we're working together is basically just a layer which gives this assurance that, yes, this is the order in which it will be returned there. And, you cannot bypass this thing. So, yeah, so that's my quick trust assumption overview on Synchronous.
Cool. Maybe Ilya, anything to add there?
Yeah, I think to kind of add to Zaki's point, the complexity here is because you have a lot of moving parts that require pretty much kind of building another blockchain, right, to coordinate that. And that's why I mean, what Shiram was describing, if you want this kind of commitment that this multiple of these rollups will include something, like for them to actually commit to that, they need to use something where they will be enforced to not be able to publish alternative block, right? Then that system itself can actually accept the shared transactions that will go into all of them, because like that enforcement can happen there. And so you kind of like, you're moving very clearly toward, still having like a blockchain that coordinates all that. And like, how exactly you design that blockchain is, obviously various design decisions, but like it becomes that like, okay, well, now everyone who wants to opt into this, right, they need to pretty much use this blockchain to see if like somebody bought the space from them, include that. That should be kind of the the prefix of the block, for example. You need to have an ability to enforce the execution itself, like, because I mean the really important part to understand is that EVM is not designed for multi-chain. I think that's a kind of really important. And what it means is that, let's say you want to do a flash loan between two different chains, just the address space, your message dot sender, all of those things don't work really well, right? And so if you want to do actual like synchronous composability between these two domains, you need to have somewhere not just execution, but you need to provide back the outcome of this execution. So you need now to have this sequence, like the sequencers that presumably if we have it opt-in mode, right, they need to have their own sequencing plus an ability to accept somebody else's, not just sequence, but executed transactions with commitment and with presumably proofs that this is a correct execution, right? So there's like a lot of kind of component need to go into this. Where the alternative is you just say like, okay, we'll sell the whole block, and they just kind of load up us again with the full execution proof, with state witnesses and kind of all of those things to like include that. And so all of that is just like super complicated, and kind of you end up in a way going closer and closer to building like a kind of a blockchain that you wouldn't need the rollups in. And maybe there's an architecture that is more like optimal for that. So like on Near, for example, a lot of the pieces of designs of standards are designed to be multi-chain. So like our token standard is multi-chain by definition. For example, contracts like Uniswap is able to receive messages from other chains, because on Near, any other contract in a way is another chain. And so you need some of those details as well for this to truly work in kind of a more, like I would say, simpler way. And I would say with the current EVM implementation, it will become super complicated, and we'll have like collisions of addresses and other things that potentially people will exploit.
Interesting. I'm not sure I agree, but Ben, maybe you have a different view on like the sort of complexity and just like how difficult it is, how complex it is to move to like a PBS plus shared sequencing system.
Yeah, I mean, I think what Ilya is talking about is more about the EVM itself, and whether the EVM itself is set up to just receive messages from each other if you have different instances of the EVM. So I guess what I'm going to comment on is less specific to this. I'll let you guys have that debate. And more about just, what is the technical complexity of this coordination layer that I'm talking about. And so if you think about rollups on Ethereum, they already are coordinated through Ethereum, right? The model is already that you have Ethereum as a coordination layer. And so the question is simply, how do we improve on top of this? Right? The the solution we have at Espresso, and it's not that it doesn't have technical complexity to build, but it's still within this same model of you have many different rollups and they need to share some common infrastructure, just like they share Ethereum for data availability and settlement. They can share a mechanism through which we decide, and it's a consensus protocol, right? The results of auctioning off proposer rights for chains. So this is a consensus protocol that also provides what Sriram was talking about of finality over the results of not only who was given proposal rights over different chains, but what they proposed in such a way that they cannot equivocate. And so you could use Ethereum for this. You could, in a very naive way, just use every Ethereum block to record this. It would just be less efficient. And so that's why at Espresso we have a BFT side protocol that is used in order to determine the outcomes of this, and we allow the L1 proposers to simply participate in this protocol on the side, and this uses eigenlayer restaking. But ultimately you do need to design some kind of, again, just to summarize, you needed to design some kind of coordination layer. You need to have consensus among the rollups on what was the result of this auction, which rollups are proposing for themselves, which rollups have delegated their proposal rights for a given slot to a shared proposer, and what was proposed. What ended up being proposed? How can we prevent equivocation on what was proposed? That's fundamentally what is required here.
Yeah. I think maybe because I totally agree with that, and that all makes sense. The question is, how do you go from there to actually synchronous composability of two, for example, EVM rollups, right? And I think that's where it's complicated.
Yeah, and so that's where, as a special example, if there's a proposer for two different chains, let's say they're within the Polygon ecosystem, then this proposer for those two different chains can now, using the Aggregation design, start, as it's constructing the next blocks of both of these chains, can queue messages and pass messages between the chains and create proofs and then aggregate them at the end. And that's why Aggregation beautifully fits in with this model. This model provides an ad hoc coordination layer that enables things like Aggregation. I think, though, Ilya, that, and correct me if I'm wrong, but you're sort of pointing to, okay, how do we actually design the two chains to receive messages from each other and pass it between applications? And then is the EVM really designed well to do this? How complex is that?
Well, I would say what you described is perfectly fits with a synchronous composability that, for example, Near is well doing. But when you say something like, I think people expect, let's say just flash loans as like a canonical example of this. And so you can imagine, if you have a flash loan on one rollup, and then you're trying to swap that flash loan, for example, you're doing like a triangular rebalancing, right? Mm-hmm. You're trying to swap on the other one. You need to overlay pretty much the balances of the account that don't exist on that chain, right? And so now if you have, you need the machinery on the other side to know how to deal with pretty much non-existing balances.
I don't think that's necessarily needed. Like, for example, in the three trust models, the simplest trust model is you trust the builder. The builder actually has awareness of both the chains, and the builder is basically like taking the risk and actually doing the atomic swap. You go one level up, the builder can put up more than enough cash on as to the flash loan and actually go and execute it. So the chain's state transition functions are themselves unaware of this external complexity. But then the ag layer design would be that, just to finish this, the ag layer design would be that the two chains can make progress only if the blocks are simultaneously valid. And so that would basically make it that when you also know that there's a joint builder, then you get exactly the atomic composition feature that you want.
This builder is building for both rollups. It's building the next block for both rollups together. It's executing for both chains. And it's simply that the extra complexity is in the fact that you can't just make a contract call from contract on one chain to the other without passing a message that has a proof attached to it. And that's where the additional complexity comes from.
Yeah, so we did get the 1 minute warning, and so I don't want to cut anyone off without like an outro, but maybe we'll just go really quick, like 15-second closing thoughts. Ilya, starting with you.
Yeah, I would say like, because we kind of, I think Shiram touched on it. I think there is a approach of intents where as a user, you describe the intent and then you have the block proposers, builders, searchers, whoever else figure it out how to deal with it and not actually needing to figure out how exactly transaction is routed across many chains. And I think that is how we're gonna get to the kind of, from a user perspective, what users looking for in synchronous composability. And then like all of the technology we are all building here is infrastructure behind the scenes and users just saying like, I want this, figure it out, swap between 15 chains if you need to. And so that's kind of what we're working on, this chain abstraction. So I'm inviting everyone in Denver to join Chain Abstraction Day.
Awesome. Shout out to Chain Abstraction Day. Sriram.
Also such a good name for the concept, chain abstraction. I go back to the dimension I was always talking about, trust. When you're thinking about composition, we need shared trust, we need cryptoeconomic trust. That's what we're building at Eigenlayer. So any of you want shared security or economic trust for doing any of this stuff, feel free to reach out to.
Cool. Ben, any closing thoughts?
Yeah, I think just to coming back to this, the importance of coordination and the fact that coordination will happen anyway. So we should design around it in a way that it's, done to minimize risk, because if we have more risk and lack of coordination, it is going to lead to more centralization and pitfalls for users.
Completely agree. Zaki, any closing thoughts?
I think this was like I think this is like a kind of a good survey of the like issues that like things like the abstraction layer, chain abstraction, asynchronous composability protocols, like trying to have like native interoperability more widely in the L2 world are all trying to like get at, and it's like we're all trying to kind of figure this out together. I think it is probably the most exciting thing happening.
Awesome. I agree. That's a great way to end it. But thank you all very much for being here. And thanks for the really nice conversation.
Thank you, Brendan. Thanks, everyone.
Yeah, thank you all so much. And so, we're going to go ahead and go to the next panel in a second. But first, I want to mention that for anyone going to ETH Denver, Polygon has a bunch of stuff going on, but the thing I'm most excited about is the Ag Cave, where we're going to have whiteboards, a few panels. We're going to have people from inside and outside of Polygon throughout the day, just kind of geeking out to a lot of the stuff you heard. So if you really like what you heard today and here, please, please, please go to that. We're just going to be walking around. There'll be places to sit, really good food, and just kind of deeper stuff like this. Thank you all again. I'm going to use my ultra powers to remove you. Let's see. Boom, boom, and boom, and boom. Oh, Serum, I'm sorry. There you go. All right. Now we're going to add the new panelists to the stage. Let's see. I think, is that everybody? We got it. That is everybody. So we're going to be going into this panel called ZK is the Endgame. We have Mihalo, Justin, Uma, actually Mihalo from Polygon Labs, Justin from the Ethereum Foundation, Uma from Succinct again, Togrel from Scroll, Jordy from Polygon ZKVM, and Bobbin from Polygon Miden / their awesome Grim Reaper icon. All right, so if we could take down the slide, I'll pass it over to Mahalo, who's going to be moderating this panel. Mahalo, go ahead.
Thanks, Hudson, for resurrecting me. I promise this is the last time you will see me on this event. Hi, everyone, again. Mihailo, co-founder of Polygon. And for this panel, I'm joined by 5 gigabrains of ZK. And we're going to discuss why ZK is the end game. So the title of the panel might be a little bit audacious. Some people at least might find it that way, or a little bit kind of bold, or maybe even controversial. But we were smart and we invited only people who generally agree with this statement. So this should be a smooth sail, hopefully. Yeah, so I'm joined by Uma from Succinct, Justin Drake from Ethereum Foundation, Toggle from Scroll, and Bobin and Jordi from Polygon. And yeah, guys, can you quickly first introduce yourself? And if you can think of one funny or interesting thing about ZK or your journey in ZK, or something that people can find interesting or funny. Yeah, I guess ladies first. Uma, over to you.
Yeah, my name is Uma. I'm one of the co-founders of Succinct, and we're building core infrastructure to try to make it easier for anyone to use ZK. Most recently, we launched SP1, which is a ZK VM that lets anyone write Rust and then get a proof. Funny story. Oh yeah, one day I think when at the beginning of when I was doing ZK, I think I spent a week debugging something. Actually, it was with CirCom, which is what Jordi, the library Jordi had written. I was debugging something in CirCom. I think at the time CirCom didn't have print statements, and I spent a week debugging something that ended up being like a one line of code change that fixed my problem.
Okay, awesome.
I'm really sorry, Uma.
No, it wasn't your fault. It was my fault.
Okay, Justin, do you want to go next?
Sure. Justin Drake from the Ethereum Foundation. I guess funny story. Like I think Snox got me into Ethereum research. It was one of the first things that I really wanted to scratch as an itch, as a Bitcoiner, kind of understand how they work. And I emailed Eddie Ben Sasson, and he invited me to a conference where Vitalik was there, and I remember having this discussion with Zuko and Vitalik, and I think that kind of laid the groundwork for me to eventually join the Ethereum Foundation. I'm also extremely bullish on ASICs for Snock proving. I guess I was a little too early, maybe half a decade too early talking about them, but now they're starting to materialize, which is lots of fun.
Awesome. But you're going to be remembered as a pioneer on the bright side of ASICs.
I don't know about that.
Okay, Toggle, over to you.
Yeah. Hello, my name is Togro. I'm a contributor at Scroll. We are a ZK VM rollup building on top of Ethereum. Funny story about ZK. I think the first time I've ever learned about ZK was back in university, and I wasn't really familiar with cryptography at the time, and my first assumption was, oh yeah, it's some kind of a mathematical structure that doesn't require any knowledge to actually use it. But then obviously after spending some time in crypto and in computer science in general, I realized that yeah, you actually need a lot of knowledge to work with zero knowledge proofs.
Awesome. Bobin.
Hey everyone. Yeah, I'm Bobin from Polygon. I'm specifically leading the Polygon Miden effort, which is different role, but still very much part of the Ag layer, the different execution environment, so to say. Funny story about ZK is that I remember, I think maybe almost a couple of years ago now, I put together some puzzles for ZK Hack. And as part of the putting together puzzles, you want to put some bugs in there so people can find them. So I put in a bug in like missing constraint bug, for example. And then people found the bug, but then people also found bugs that I didn't intend to put in there, which got in there by mistake. So that was pretty funny that people found more bugs than I intentionally wanted to put in there.
Okay, awesome. And last but not least, Jordi.
Well, yeah, I'm Jordi Bailina. I'm the technical lead at Polygon ZKVM. For the story, as mentioned before, I also created Circum back in 2017 or something like that. Actually, Circum was, I built the first version of Circum in a weekend mainly to learn how ZK work. Actually, I spent more time trying to understand Vitalik's paper, Vitalik's blog post by the time that writing Circom itself. I mean, the first version of very sketchy, just to learn on that. And well, after just some iterations on that, I remember one guy, and it's funny that a random project that they wanted to build a mixer using Circom. I just tell guys, this is just, I mean, was not ready for doing any production ready. I mean, if you are crazy and you want to do it, it's up to you. But even that, I get a lot of concern. I mean, this project was called Tornado Cache by the time, and I remember that. I mean, they launched it. There was some bugs in Circom. They hacked themselves. They fixed, and it was this is how Tornado Cache was, and was one of the first projects that using Circom. Right now, Circom is quite. I would say it's quite a standard in the space. Probably the technology is getting a little bit old, especially with the newer Starks and all these new proving systems. But yeah, that's a little bit how I started in the space on the ZK part.
Very nice. Thanks, everyone. I will say my interesting, funny / embarrassing story just to make everyone feel better. So back in the days, I guess in 2017-ish, when I was going down the rabbit hole of blockchain infra for quite a while already, but ZK specifically, and I remember, among other posts, Justin Drake's post from back in the day, Medium posts about ZK. Maybe you don't even remember them, Justin, anymore. But anyways, I got some kind of a brave idea or opinion that I can fully understand snarks. And I kind of invested like a week or so into that effort. And then I just definitely gave up and said, okay, this is not for me. Starks, I can still kind of wrap my head around. But yeah, I just realized that there are limits to things that I can understand. So that was a very humbling experience. Yeah, with that being said, going back to the topic of the panel, why ZK is the end game? In my opinion, I will put that kind of as a intro statement, it's because ZK is the only technology in our industry that seems to have the potential to solve basically the major challenges of this industry and major kind of obstacles on the path of becoming or going mainstream, and addressing or being utilized for some of the most important use cases. Like genuinely, there's no other technology like that in the industry. So I would just name a few of these challenges and use cases, and maybe we can go into them one by one. So the obvious and the most kind of explored one at the moment is scaling. Then obviously privacy, because that's kind of the original use case for zero-knowledge cryptography. Then interoperability, decentralization, identity, and beyond. Basically, the list goes on. But I would say these are the main kind of the main topics that the industry is focused on at the moment. So let's start with scaling, and I would maybe hand this over to Togrul. And Togrul, if you can give us basically kind of an overview of why ZK is so interesting for scaling, and then others please chime in. Maybe we can go through this together. Togrul, sorry, you're muted.
Compression functions, which just allow us to compress many different. Oh, can you hear me now? Yes. So what I was saying was, I think from the perspective of scaling, you can see zero-knowledge proofs as a sort of a compression function that allows us to compress different things. So in case of validity proofs, we compress execution. We can also compress data. So rollups also use zero-knowledge proofs to compress data. And that causes a lot of different things. So, for example, you can use ZK on a consensus level to prevent, if we have real-time proofs, to prevent re-execution of transactions, of the ordering, and basically speed up a lot of things. And you can apply ZK in a lot of different facets of distributed systems and just optimize things and make them run faster and consume less resources. And basically, again, we go back to this end game of having a few powerful nodes doing a lot of computation, and everybody else having these light or stateless nodes that can just verify things and interact with everybody else without having supercomputers or even high-end consumer grade machinery at home.
Okay. Does anyone else want to add anything or pick up on the topic, or we move to the next use case? Okay. I think, yeah, use of ZK in scaling is very much explored at this point, and you guys at Scroll are doing a great job, obviously. So let's move to privacy. I know at least two persons here very passionate about the topic, so I would hand it over to Bobin first, and I'm sure Jordi also would like to chime in, but others also feel free as well. So ZK and privacy.
Yeah, I think, I mean, it's very difficult to imagine how you would do like a very, user-friendly and at the same time private kind of system without ZK. I think like for simple payments or something like that, maybe you can solve it without like hardcore ZK, where you can use like Elgamal encryption or something like that. But as soon as you try to do something more complicated that is actually maybe useful for the user to maintain their wallet, I think without having ZK proofs, or without actually people being able to generate ZK proofs on the client side, it's going to be way like, I don't even know how we would do it. So without ZK, in my mind, there is, we can get to like, this pseudo-anonymity that, let's say Bitcoin started out with, and maybe you can add a few more features. But if you want to have like, a user wallet that is able to execute some logic on the client side and, interact with the rest of the chain, like in a composable way and all of that stuff, you do need ZK. There is no way around it. I think, and in general, like I think this is a very important aspect of blockchains that we want to like. I know right now a lot of people are focusing mostly on scaling, but I think privacy is very crucial in my mind for the user adoption in the long term, because we want to have a situation where people don't reveal, balances of their accounts, or it's not easy to track them and all that. We want to have this the world where, it's better than what you can get with a traditional kind of banking system, and it's not kind of like you have to make trade-offs where, like, yes, you can do it in a censorship-resistant way, but then you have to give up a big part of your privacy and all of that stuff. So I do think, like, if we want to bring in billions of users into blockchains and crypto, you have to have privacy, or at least some way of addressing the privacy kind of limitations of what we currently have. And I think obviously privacy is a very kind of like charged topic in ways, especially around regulation, because obviously Tornado Cash and others, it's very difficult to kind of please everyone on that front, and we need to figure out, and hopefully over time there will be more regulatory frameworks around like what is kind of acceptable and where we want to push the boundaries a bit more. And we want to, but I don't see how like we can stay in the current state without actually getting to price, and ZK is the only way to do it. I also do want to say that like one thing about scaling, which it's kind of related to privacy, is where you can actually generate proofs on the client side. This is a very interesting, like where it's a stateless kind of like, you can think about stateless wallets where you only put commitments on chain, but you actually run your logic of a smart contract or your wallet on the client side, which both helps the privacy and scalability because it naturally offloads what what the network needs to do on your behalf. It just needs to verify a proof of your transaction, and yeah, you get both privacy and scalability that way. And in my mind, like only ZK can offer it.
Okay, awesome. Jordi, do you want to add something? I think you want to add something.
Well, yeah, I mean, we live in a world that we communicate a lot. I mean, we are sending in internet, we are sending a lot of information around, and we prove almost anything about the information that we are sending. So the ZK is actually what helps is, okay, let's give away just the required information. So it's like, it's not about hiding, it's about sending just what the information that's required and this information be proved, be authenticated, it's a valid, it's a trusted information. So ZK, it's a technology that allows to go in this kind of world, where we are more in control in the communications that we are making, and that the communication that we're receiving, the information that we're receiving, is more trusted, is verified, is verified information. Of course, this is very the beginning, and this is very theoretical, but the ZK is the tech that allows to go in that direction. Thinking about privacy, I know that's a little bit controversial, but all of us, we need privacy. We don't want to reveal all the information to everybody. It's like we want to control what information we want to give away, and we want to also prove that this information comes from a trusted source. And this is, ZK helps here and can help a lot.
Yeah.
I would agree with Sergio. Actually, maybe a better name is that ZK gives you the power to selectively disclose only what you need to disclose, rather than like having to disclose everything. So ZK is the technology that privacy is too broad of a term, but a selective disclosure may be a better term.
Yep, makes sense. Anyone else wants to chime in on this topic? A small comment from my side. I think, as Jordi said, the privacy topic is a little bit controversial now, given all the regulatory scrutiny or unclarity, at least. But as Bobby said, I think it's really important to understand if we want to take this industry mainstream, we really need to have privacy. Privacy is a strong requirement, both by retail, by end users, because it's kind of a basic human right? And that's how traditional financial system works. If I'm using Venmo and I'm sending money to other people, of course, no one will see my transactions. That's how we already. That's how things already work. And on the corporate enterprise side, enterprises have business requirements, legal requirements to not disclose data, different types of strategies, and all sorts of things. So yeah, again, long story short, privacy is definitely a strong requirement. I would say if you're thinking about taking this industry mainstream, that's something that really should be understood, I guess. With that being said, I think we can go to interoperability. I would hand this one over to you, because you guys are doing great work on the interoperability, ZK-powered interoperability side, and there are already two concrete outputs of your work that we are learning from and we're going to utilize. One is the ZK consensus that we are probably going to use for the egg layer and plugging POS chain into it. And the other one is your work on the shared validity sequencing that pretty much inspired the whole concept of egg layer, at least to a certain extent. So yeah, great work that you guys are doing over there. And can you maybe shed some light and share some thoughts on this topic?
Yeah, I think at Succinct, we've done a bunch of work on ZK bridging, and basically kind of like helping connect all these different chains and all these different ecosystems, utilizing the power of ZK. I think ZK is really nice because it provides this like simple primitive that you can kind of rely on, and then know that, for example, the validators of some layer 1 or whatever have signed off on like a certain state. And so you can just get this like cryptographic proof or cryptographic truth that like some action happened, and you don't have to like worry about all these like trust assumptions like multi-sigs or intermediate chains or whatever. You can just like go direct kind of to the source and verify claims in like a very computationally efficient manner. I also think the work Polygon is doing with the aggregation layer and ZK is uniquely enabled by ZK, because now you can have this like really fast interoperability between all these different rollups. And I think for the end users, hopefully that's like very simplifying. I think if people like try to use L2s today, it is like a very arduous experience, because the chains don't talk well to each other. You have to like use these third-party bridging protocols, and hopefully ZK can move us to a world where you can get like very instant or close to instant bridging, and you don't have to like worry about this like complicated set of infrastructure on top. I think ZK is like very simplifying in that way. So I think that's why it's very important for interoperability.
Totally agreed. Anyone else wants to add something or chime in?
Yeah, I'm especially interested in this interop at the L2 layer. Like if you try and bridge between two L1s, there's like these fundamental constraints. You don't have shared security, and you can have one chain reorg but not the other, and it becomes a bit messy. But if you work at the L2 with rollups, you can have a system which is extremely clean, where in some sense you don't need bridges, and I think the near people call it on-bridging. And Snox is one of two pillars required to achieve this on-bridging vision. The other pillar is shared sequencing. So once you have two or more rollups that share a sequencer, and you have real-time proving, then you're in a position where you can do real-time settlement, and now you've unlocked synchronous composability across this these rollups. Now, one of the, I guess because we're talking about Snox, one of the valid questions is, do we have this Snox technology today? Like, can we do real-time proving on the order of tens of milliseconds or maybe 100 milliseconds? And even though we don't have it today, I think we'll get it in relatively short order, given the progress that I see Jordi's shaking his head, and so is Michaelo. We have Axial already that came up with a Snox ASIC, and we also have SciSIC and Fabric that are also targeting an ASIC for 2024. And I think folding is also one of the key ingredients to get there, where you can do like massively parallelized proving, and therefore bring the latency down to a minimum.
Yep, makes sense. Thanks, Justin. From our side, when we started Polygon back in 2020, we intentionally started as an unopinionated kind of platform, and we still were exploring both optimistic or fraud-proof based scaling solutions and ZK-based scaling solutions. And relatively soon after that, within 6 months or to a year, we developed a strong conviction that ZK really is the go-to technology, and that's when we published our ZK thesis and committed this huge amount of funds from our treasury and went all in basically on ZK. But why am I saying this? When we made that decision and developed that conviction, we mainly were considering advantages when it comes to scaling specifically. So building fraud-proof based L2s and ZK-based L2s, and they are these kind of differences are very much explored at this point. Capital efficiency, the fact that you can immediately withdraw funds, no need for additional party that will submit fraud proofs, etc. Not to repeat all those things that have been repeated so many times. But what we another very fortunate realization that came later was were the advantages of ZK when it comes to interoperability. So seems like in fraud-proof based systems, in multi-layer 2, fraud-proof multi-layer 2 environment, you simply cannot achieve that level of integration, that level of unification that ZK allows. It seems like it's simply not possible. So that was another very important and very fortunate realization that we had after we went all in on ZK. So yeah, just basically from my side. Okay, the next topic is decentralization. I would like to hand over this one to Justin. And yeah, Justin, you have been exploring different applications on the core protocol or L1 level, like light clients, fast syncing with ZK, all these things. So if you can maybe chime in, maybe improvements on the consensus side, and just basically an overview of how ZK can help improve this decentralization by being used on the core protocol or L1 level.
Right. I mean, the TLDR is that we can Snockify everything. And I say that's what it's called in Vitalik's roadmap. So we can Snockify both the beacon chain and the EVM. And so what that means, for example, is that if you're currently running a Geth node or whatever it is, a ref node or whatever execution client, you won't have to in the future. And the reason is that you can just be told what the state root is or whatever piece of state you're interested in, and you'll be given a SNOC proof that it is correct. And so the hardware requirements to run a node go way down. And that's relevant for entities like validators, especially if you're a solo validator. And the vision that I have is that you'll be able to validate on your smartwatch. So you're kind of walking around in in your town or village, and you have your validators on your smartwatch. But yeah, it's not only for validators, of course. It's for any application that needs to know what the state of Ethereum is. And so if you have a decentralized Uber or decentralized Airbnb or whatever application, and you need to know what the state root is, then you can have these light clients know the state with essentially like zero resources, minimal in terms of bandwidth, minimal in terms of compute, and like no disk IO, no nothing. So in terms of the path to get to this end game, I think what we're going to see is permissionless innovation that happens without any hard forks. So anyone can just try to snockify the beacon chain or try to snockify the EVM. And we're actually starting to see that in 2024. And then once we have sufficient confidence in the infrastructure, so we have multiple implementations, we have hardened those things, we've done lots of audits, then we can consider enshrining it at layer 1. Yeah.
Okay, awesome. Anyone else wants to chime in?
I think one thing that is interesting, and this is more about like decentralizing, let's say, proving of block production on layer 2s potentially, is that right now we have like a single prover that like builds the proof. But in theory, we could like, and maybe that will require some changes, but you could say, you could, and the way that it's done, you have a bunch of transactions and you roll them up into kind of recursively aggregate them using ZK proofs. But it would be interesting to see if you can kind of like decentralize this roll-up process so that, like there's a batch of transaction that is being proven in one place, kind of like block building, and there's another batch that is being built by another actor, and then the final block producer just takes about, the final few batches and puts them together into a block, and like the actual proving is decentralized across network as well. It's an interesting thing. I haven't like fully thought it through, but it's something that I'm very curious if we can make it work.
I think that intersects with what Justin is interested in at the moment quite a lot. Sorry, Justin.
Yes, but there is a bit of a trade-off here, which is that if you want synchronous composability with one shared sequencer, then you actually have to do the proving in real time. So imagine that you have some sort of super transaction that wants to go in and out of rollup A, but also in and out of rollup B. Well, now you need to have the proofs in real time. And so as soon as you start decentralizing the proving, then you lose this real-time aspect. So I think that is a real kind of trade-off of shared sequencing, is that it's not as friendly to decentralized proving. But the way that I think of decentralized proving is as a fallback in case the primary sequencer, or whatever it is, stops working. So in particular, you can use these decentralized provers to build L2 blocks that get included in inclusion lists. So for example, if there's censorship, that's fine. You have a slightly higher latency system that brings these transactions on-chain via the inclusion lists.
But I think like the real-time proving is not too far off. It may be, it's probably not this year and maybe not next year, but it's certainly in my mind within like 2-3 year time frame where we can get to, very close to real-time proving.
Yeah, I mean, even our latest release of ZK EVM has already per transaction proofs, right? We are still not talking about real-time proving, but it's relatively close. Depends on basically what is your reference. But yeah, I agreed with Bobin. And also one thing, do we need real-time proving for all the transactions, or we only need them for cross-chain transactions, right? So we still can prove batches in some regular intervals. Only these cross-chain transactions that need to have some priority when it comes to proving, that can also work, right? And that will present much lower overall load on the entire ecosystem, I would say.
Yeah, that's a fantastic point. So what you could imagine, for example, is the top of block or top of blobs have like 2 or 3 like super high value transactions, which are synchronous. And then everything else, the 99% of the block is just like asynchronous stuff, which is super cheap, for which the proving can be delayed to the next block.
Exactly. Like in a traditional banking system or financial system, you can pay a little bit more if you want your transaction to go through immediately. Like this priority transaction, you pay a little bit higher fee and your transaction goes immediately. Otherwise, you wait for the settlement. And in this case, settlement will be in 20 minutes or 15 or whatever. Otherwise, it will happen immediately. Yeah. Okay, cool. That was a nice discussion. Let's move, in the interest of time, let's move forward to identity. I would like to pick your brain already here. I know you're focused on zkVM mainly now, and that's your only focus, but you are familiar with the concept of course, the decentralized zk-powered identity, and if you can just basically shed some light on the use case.
Yes, I mean, identity, we were been talking a little bit about before, but at the end, I mean, identity is what you know about the others and what the others knows about you. Okay, this is what defines this identity. Or this information, we can call them claims, okay, or they can be piece of information that actually you know about. So at the end, in identity is, well, when you want to share this information, when you want to prove something about your information, this is where the ZK makes a lot of sense. At the end is you are asking somebody about some information, the other person is providing you to that information, and it's proving to you that information. And here, I mean, issuers can be individuals, but can be governments, can be companies, can be any authority. There's authority, and the recipients of these claims can be individuals, but I mean, individual can have different identities, or even a bot or even an object can be their own identity. Okay? So at the end is having for me, identity is at the end is a system. It's a huge database of claims where each individual holds part of this information, and then you are doing queries on this database, this decentralized database, making queries and proving that these queries are valid. I mean, this is the base for I understand as an identity system. And of course, here zero knowledge is in the core of the technology. I mean, an identity system without zero knowledge. I'm not even sure if it's, I mean, it's possible, but then you lose this privacy, you lose this control of which part of your information you are giving away.
Yeah, absolutely agreed. And again, that privacy, as Bomin explained previously, and you, Jordi, also is, in lack of a better word, compliant privacy, even though some people might not like this word, but really like the properties of ZK allow full privacy towards the entire world, pretty much, and you still can comply with anything you want to comply with. You can disclose any portion of the data that is kind of hidden by zero knowledge cryptography, etc. So it's still possible to have I would say realistic mass adoption. Because I think that kind of cypherpunk, full-blown privacy world is utopian one. I would say maybe some people will disagree, and I think it's probably for the better, to be honest. But this is some philosophical debate now. Anyways, long story short, ZK as a technology allows implementation of identity protocols that are fully private, yet allow you to disclose any portion or any kind of information held by your identity account or storage to any party that you want. So that's a very important property, I guess. Okay, and I would just like to ask everyone if you have, let's go beyond all these use cases and challenges. If you have anything that we haven't mentioned here. For example, I remember just in reading those Medium posts from whatever 2017, when I used to read everything I could get my hands on ZK related. You were mentioning some interesting, crazy ideas, having Ethereum with only a single opcode that verifies ZK proofs and remove all the other opcodes and whatnot. So anything, guys, that you want to maybe bring up that comes to your mind that can be some additional use case or implementation of ZK?
Here, probably I would like to mention one of the applications that I think that we will hear a lot in the coming years, and is the multi-party computations. I mean, if you understand ZK as you are an individual, you have some data, and you want to process this data, and then you prove that this process is valid. So here, imagine that instead of being a single individual, you have like many individuals that they want to do a computation, and you want to compute a result, but that comes from information that comes from many individuals, and you don't want to share these individuals. You want to keep this zero knowledge preserving there. I think this is an amazing idea and an amazing technology. ZK is again a fundamental piece for all these kinds, and this allows individuals to have this shared knowledge. I mean, it's just without revealing your information, you can know something that's like the aggregation of all the data of many people here. So here, a lot of applications will come on that, and I think this is a really cool technology that we will hear more in the coming years.
Okay, thanks, Jordi. Justin, can we have Ethereum with only one opcode?
Yes, and in some sense, we are moving towards that future, right?
So you saw it 5 years ago.
Well, actually, I had completely forgotten that I wrote about this. And Vitalik is very interested nowadays in massively simplifying the execution layer down to one opcode. But even in terms of things that we have planned is to snarkify the EVM. And basically, from the point of view of a validator, you just have to verify this one snark. But what we can actually go much further, which we can create a ZK EVM verification opcode within the EVM, so that if you want to deploy an EVM equivalent rollup, you can just benefit from this one opcode. So instead of building some sort of crazy multi-prover, multi-verifier ZK EVM, you can just use this one opcode. So that should dramatically lower the barrier to entry to building a ZK EVM equivalent rollup. But it has actually another superpower, which is that it stays equivalent as Ethereum hard forks. So let's say that if Ethereum makes a change to the EVM, well, now if you want to be EVM equivalent, how do you update your circuits? And like the only way that I know for rollup today is to use governance. But unfortunately, governance, if it has the ability to modify the circuits, that's an attack vector, because someone can take over all the tokens and then make a vote which will just change the circuit in such a way that all the funds go to the attacker. And so with this one opcode, we can remove the need for governance on execution specifically. And then another really cool aspect of this is that if there is a bug in the circuits, and there will be bugs for some period of time, then the layer 0, the social layer, can fix it. So we can update our clients. On the other hand, again, like if you have a critical bug, you're going to need governance to go ahead and fix it at the rollup layer.
Mm-hmm.
Would having that single opcode require to enshrine some proving system, or can it be done in such a way where there is no enshrinement?
Right. That is a good question. So one of the really clever ideas by Vitalik is that the proofs are actually off-chain. So they're kind of gossiped at the peer-to-peer layer, and they only affect the fork choice rule. So let's say that there's 5 clients, execution clients. For example, Geth has a prover, and it has its own kind of Geth snark, and that gets broadcast. And then as a validator, I kind of choose what proofs I'm going to listen to. And if it happens that Geth snarks have a bug, well, I can now update my client and run the ref snarks. And so the cool thing here is that you can have the client diversity at the fork choice level without enshrining any specific circuit or any specific prover for this one opcode.
This is very cool. Okay, they are warning us that we have only a couple of minutes left. So yeah, just to wrap up what we have covered so far, even though I was joking in the beginning that this statement is controversial, I think at this point there is general opinion or rough consensus in the industry that ZK is the end game. And as we have covered on this panel, there is indeed no other technology that can solve all these challenges, address all these use cases like scaling, privacy, interoperability, decentralization, identity, etc. So it really is a fascinating and I would say critically important technology. I would like to hear from you guys two things. One, why it might not be the end game. What can go wrong possibly in your mind? And because we don't have time for another round after that, if you can share any closing thoughts in regards to that or anything apart from that. So yeah, these two things. Uma, over to you, please.
Yeah, I think maybe in general, like the social layer of Ethereum and like the ecosystem needs to emphasize more that like security actually matters and things like that. I think one thing that could be really bad is if one day there's this like something bad happens and there's this like catastrophic failure of like systems that aren't secure, and then everyone realizes, oh, in hindsight we should have been using ZK but we weren't. And I think it's like important to kind of preempt that and encourage people to like have security and like, pay for security and, go through a little bit of extra work before we have something that like makes it really, really obvious. And yeah, I think the ZK tech, my closing thoughts are just the ZK tech is, I feel like pretty ready, like inexpensive and rapidly getting cheaper today. So hopefully we see that future sooner rather than later.
Fully agreed. Excited for that. Togor, do you want to go next?
Yeah, I actually wanted to follow up on what Uma said. I think the ZK tech is almost there, and we're at the point where we can use things that were difficult to imagine a few years ago. I remember having a conversation in early 2021 with someone whom I really respect, and there were just rumors going around that Jordi is building an EVM compatible EVM equivalent ZKVM, and that person said that Jordi is insane. It would never be possible to do that. And here we are, just 3 years later, and there are multiple ZKVMs on mainnet that are almost or entirely EVM equivalent, and it's just and the technology just keeps improving. So there are still things that we can improve that will allow what Justin describes in terms of synchronous composability, etc. But it's been an insane few years to be involved in terms of how much the technology improved. And
for sure. Justin, you want to go next?
Yeah, I'm also excited by the commoditization of SNARKs because it means that they can be used as a primordial building block in the rest of cryptography. So SNARKs are very useful in MPCs and FHE, and they're also useful, for example, if we want to do post-quantum signatures, right? Like one very easy way to do a post-quantum signature is to have a stock of knowledge of some sort of a hash image. And you can also use SNARKs for aggregation of signatures. And that's one of the big problems that we're faced right now at L1 is, how can we very, very quickly aggregate 1 million signatures? And I think SNARKs can provide an answer there. And also SNARKs are used for like this crazy futuristic cryptography, like witness encryption and IO and one-shot signatures. It's always a building block in these constructions, and I'm hoping that they become as commoditized as hash functions, which are also used everywhere.
Okay, awesome. Bobin, do you want to go next?
Yeah, so I think why ZK might not be the end game. Like I can think of a couple of reasons, but none of them are the reasons like which put us in a world where probably would be pleasant to live in. Like one is maybe there's like some fundamental flaw that is found in cryptography that affects like all ZK proving systems, and in that case, I think we have much bigger problems, and it's not just ZK related. And probably a very unrealistic scenario, but then again, if that happens, it's like not going to be a fun world to live in. And the other way is like more on the social side, where for whatever reason, similar how like encryption was considered to be too like sensitive to be handled by mere humans, like maybe governments will decide to ban use of ZK for some like because you can do various things, and maybe it will get criminalized or something like that. And again, this would not be the world that I want to live in if that happens. But like aside from like this extreme unlikely scenarios, I can't imagine like why ZK would not be the end game for at least for blockchains and probably many other applications as well.
Okay, awesome. And Jordi, why it might not be the end game, and what are your closing thoughts?
Well, yeah, I just want to express a little bit a concern that I have. I mean, it's besides security, or even extending a little bit beyond security. I mean, I remember at the beginning of the blockchain, when somebody just sent a smart contract to Ethereum, there was at least 10, 15 persons or 20 persons that verify that smart contract, that reads a smart contract, and that verifies that actually this smart contract was doing what actually they were claiming to do. This does not, I mean, I don't see this spirit anymore. And even the ZK, in the ZK, I mean, these systems become more complex, and verifying all these becomes even much more difficult. But if we build a system that's a trustless system, okay, that means that we don't need to trust. We should, and in order to trust, you need to check, you need to verify what's in there. And a little bit is just express the concern that if we are not verifying the systems, if we are not understanding, if we don't have people that just checking what's behind, this can be problematic. Here, I mean, a huge shout out, for example, to Yuma's work on all these systems. I think this can help a lot, because at the end, they're simplifying a lot the source code of the actual prover itself. I think this is a good direction to go that, but even that, I mean, verification is important, verifying that what you are doing is correct, and this is responsibility. We don't have a central authority that's going to do that. I mean, this is responsibility of all the peers in the decentralized systems to verify that what we are running actually is correct.
Makes sense. Okay, guys, we have to wrap up this one. Thanks a lot. I have really enjoyed this conversation, and thanks, Master Hudson, for not kicking us out earlier and allowing us a few extra minutes. Yeah, that's all. Thanks, everyone.
Thank you so much, Mahalo. I'm a merciful leader, so pretty much makes sense that I would be perfect in all ways. I will now remove everyone from here.
I'll remove myself.
All right. Oh, man. Okay, so this next panel and final panel is called Infinite Scalability with CDKs. We have Ajit from Polygon Labs, Chai from OKX, Martin from Astar, Alvaro from ZK Fair, and Victor from Manta Network. So I'm going to go ahead and throw y'all on there. Boom, 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 boom. And where's the last one? Oh, there we go. And the last one. All right. I think we're all set here. I'm going to pass it over to Ajit, who is going to be modding. And yeah, enjoy your time, everyone. I don't know why I'm acting like this is some kind of like theme park ride where it's like, okay, get in, enjoy, buckle up. But, buckle up. It's going to be a great conversation. Ajit, take it away.
Thank you, Hudson. Hope you can hear me. It's great to be hosting this panel with Martin Henskens, head of A-Star Foundation, Alvaro Fernandez, community contributor for ZK Fair, Victor G, an old friend, co-founder of Manta Network, and Cheng Sai Lee, head of OKX L2 ecosystem. It's great to see you guys here. So today we're going to talk about, the your experiences with the chain development kit and overall in the Ethereum L2 ecosystem, what you're building, how that's going, what your vision is, what your experience with the CDK has been, and how the Ag layer kind of contributes to what you're looking to build. So Alvaro, we'll start with you, in no particular order. So Alvaro, please introduce yourself, tell us what you're building, and how you're using the CDK today.
Yeah, so my name is Alvaro Fernandez. I'm one of the core community contributors at ZK Fair, which was the first CDK to go live. I also happen to be COO at Lumos, which is one of the solution providers, providing eventually the solutions towards building CDKs, of course, and decentralized proven networks. With ZK Fair, it's been an amazing experience so far. We were paving the way, being the first production environment that was going live for Polygon's chain development kit, and I must say so far it's been a hell of a journey. But in general terms, with the support of Polygon, with the architecture in itself, with the structure of solution providers stepping in, it's been a good journey so far. For good first 2 months.
Great to hear, Martin.
Hi, my name is Martin. I'm the head of Astar Foundation. Before I will talk a little bit about what we will be building, I will first talk about what we already built. So Astar is already a layer 1 connected to the Polkadot ecosystem, where we offer a smart contract environment where everybody wants to build on Polkadot. This is an environment that it's like an EVM compatible environment, but we also have like a Rust-based smart contract environment, making them interoperable with each other. So offering all smart contract solutions on the Polkadot ecosystem. I believe at the end of the summer, we pivoted our idea as well, and we went through the L2 space as well for expanding our tech stack. And this is where we launched our vision of Astar ZK EVM. The main reason why we launched that vision was because Astar is already recognized as one of the leading blockchains in Japan. And after Web3 being part of the national strategy of Japan through the government, we saw a lot of demands coming in from enterprises, from brands, from companies, and so on and so on. So we had to make sure that we could follow up on demand, and that's where we saw that we really need to expand our tech stack and really need to improve the infrastructure that we are trying to provide for Japan. And this is where we came as well in close contact with Polygon Labs, and this is where our visions and missions united, and that's why we are now building our L2 with the Polygon CDK.
Great to hear. So Chai, you have a very large ecosystem already, right? So OKX is the world's second largest crypto exchange by volume. And you have some really great products. I'm an avid user of your wallet and your exchange. It's phenomenal what you guys have built. So what brought you to the CDK, and what are your plans?
Yes, we do. We are like a very strong believer of ZK technology as well as Ethereum ecosystem. That is why we launched our own Ethereum layer 2, powered by not only Polygon CDK, but I believe insights and support from Polygon team. And we launched our testnet 2 months ago, and so far there are around like 300 projects already up and running on our testnet, and very soon we are going to launch our mainnet. And so far we are very happy to see all of those achievements that we have achieved, and also we are very impressed with the technology, especially the CDK technology, in terms of its EVM compatibility, in terms of its performance, and we are also very excited about the new features such as Egg layer and like other features such as like the new client that Polygon CDK will be introduced very soon. So we are very, very excited, and giving OKX as one of the largest crypto companies out there in terms of a centralized exchange, CeFi, as well as like application level, our Web3 product lines, they are also very, very successful. So our layer 2 will connect OKX ecosystem with Ethereum ecosystem with the help of Polygon CDK. Yeah.
Brilliant. So Victor, you've been building for a very long time in the, you were building for a long time in the Polkadot space. You guys have a very strong ZK team. I know Shumo was there. He's building Nebra now. And the first time we spoke, I think we had a pretty detailed conversation about your ZK work and Poseidon. So again, what brought you, given all of your ZK expertise, what brought you first of all from, the Polkadot ecosystem to the Ethereum ecosystem? And then within that, I know you guys switched from, OP Stack and Superchain to CDK. So what drove that decision? But more importantly, what you're building long-term and what's your vision overall?
Yeah, thanks, Ajit. So basically, what we are doing is we really focus on build the infrastructure for application level ZK use case. So it means a lot of application they need ZK to build some new use cases hiding information, fully decentralized voting, to hide the address or ZK credentials. All of this they need to their own circuit besides the infrastructure level like ZK rollup. So all of that we build this kind of infrastructure to make developer they don't need to learn this ZK library. They don't need to write their own circuit to achieve these kind of features. That's kind of what we are good at. But on the ecosystem, we start to deploy these kind of use cases in Polkadot, and we still run our Polkadot chain. Basically, we have the fastest prover speed in that parachain. But there's no on-chain activity in Polkadot. The whole ecosystem dead, and then we kind of build more stuff on top besides what we promised since last year. And we start to build the OP stack level 2 with the ZK application a middleware. So we call it ZK application layer. And that is the first one used last year SDA. And we initially used OP stack, but right now we are the first one going to actually building more stuff on top of OP stack. It's kind of a combination of the Polygon CDK and the OP stack. And so we add the type 1 prover on top of the OP stack to work with the CDK and also work with OP. But that's how the way work. And this can be something really new. And we recently launched something called New Paradigm. So basically it's actually something enable liquid staking token and in future risk staking token on top of us, and get more and more usage and achieve really high capital efficiency in the layer 2. And in terms of the TVL, we are the third largest besides OP and Arbitrum, and we still sit there. And I mean, hopefully still sit there with the Starknet getting more and more hype, but we are still the third largest L2.
Yeah, so I'm a user of the New Paradigm. I have a few ETH in there. I'm really waiting for that wonderful reward. I think that's the compliant word for it. So it's a very exciting overall. I think you guys built a lot of traction in TVL very, very quickly with that really exciting, degen program. Really got ahead of Blast in some ways, which is really exciting. And I mean, you also have a lot of in-house ZK expertise, which I think we'll collaborate on more. So Chai, what sort of verticals are you targeting? Because, OKX, you guys are very, very big. So, I mean, I personally think you guys are going to be much bigger than Base, right? Given how much of an ecosystem you have. A lot of our friends in the West are often not aware of the sheer reach and ecosystem of OKX. So any particular verticals you're targeting? What's the plan? Where do you start? And what sort of applications do you see being deployed on your CDK chain?
Yeah. So for short term, our target is always defined. We wanted to make sure there are a lot of capital as well as users. To be honest, we are not worried about the users because we have a huge number of user base that we can easily tap into. However, in terms of capital, I think there are definitely some kind of a lot of work that we needed to do. Fortunately, so far we already see some top like blue chip protocols they have deployed on our testnet, and more are coming, such as Fast Quickswap, Curve, and a bunch more like infrastructures such as the Graph, Anchor, and we are also engaging very closely with the Chainlink to make sure like those infrastructures, they are already available to power like a very strong DeFi ecosystem. I believe we will be able to achieve this goal in half a year, or even hopefully like even earlier. And then we are also very excited to see a lot of like very innovative and also very exciting projects such as games, such as SocialFi, and some like products they fully rely on ZK technology, such as like payment or credential identities. They are also deploying on our chain. One example is it's called like Mobi Launchpad, which is very like I believe Sandeep or even Polygon like invested into this project. It's a very their product is very impressive. They have like new idea and new features behind it. So we are very excited, and we really wanted to see a lot of like very innovative ideas, products building on our chain, because for one, we are quite confident that layer 2 will be able to nurture a lot of like new ideas or products, technologies that is not impossible on layer 2, given its like performance issues. And the second thing is our layer 2 is powered by Polygon CDK, which means like it's a ZK technology. So I believe there will be a lot of like new ideas and products that is powered by ZK technology, which is like almost I would say unimaginable on other like layer 1s or other non like ZK powered layer 2s. So yeah, we are very excited to see how our like layer 2 goes, and we are quite confident that for those top like developers, builders, artists, that we will be able to give them a lot of support in terms of users and other like investment or other like supports from our side.
Amazing. Martin, it's impossible to talk about Japan and blockchain without A star being the next word in that sentence, right? So and you guys have had a lot of success with gaming and NFTs, kind of this whole metaverse ecosystem. So what brought you to CDK, and then what's your vision? Where are you going forward in terms of and how is the overall activity on the blockchain so far?
Okay. To answer this question, I will tell a little bit regarding why we chose to spell the Polygon CDK. It's mainly because it's very aligned with our mission. Our mission is bringing, of course, the technology of Web3 to billions of users. But first, to start with the billions, you have to start with the millions. And this is why we, with our L2, focusing on enterprises and brands and adopting the Web3 into this, we are thinking of our mission of focusing on the entertainment sector, also focusing on brands who already have an existing user base. We are not targeting specifically the crypto users. We are here targeting the already existing users to bring them into this Web3 space. I think this is our mission, to really adopt the technology that we all love. And by doing this, this is very aligned with what you guys at Polygon are doing as well, by creating all those enterprise solutions together with your tech stack. And we see this as well from the demand coming from Japan, that there is a huge interest of looking into this technology. Not only because it's supported by the government as national strategy, but also Japan is looking for a way to establish themselves as well much further in the economic value of the country. Everything is now focusing on the tech nation of the US with Silicon Valley, but Japan itself also wants to be that frontier of technology. And they see this in Web3. That's why they really put heavily on this. And this is where we come in as well as a strength in Japan, not only by knowing the culture of Japan, but also knowing the technology behind Web3 and how we do this. So this is very aligned with the vision that we felt as well when talking with Sandeep and as well with you guys in Dubai. And this is where we really feel that this is the place to be to go for.
Yeah, I think most people don't realize how innovative Japan is, right? Unless you go there. I used to live there for 2 years. I go often, like once every 2 years, and the sheer amount of creativity in that ecosystem across electronics, gaming, industrials, enterprise is just phenomenal. Even financial services, the kind of tools and devices and technology you get to interface with, kind of is really always encouraging. And I think it's amazing that you guys are now bringing Japan and all of the innovation and that energy in Japan to blockchain with Polygon CDK on A*Star's network. I'm really personally very excited about it. So we'll hear a lot about it. I think what's also cool is that the global coverage of the chains building on CDK, even on this panel. I think we cover pretty much all of the geographies, all of the application verticals. But more importantly, I think there's a lot of cool technology that's coming out of that as well. So, Alvaro, ZK Fair, what's exciting? What sort of applications? What's your focus? And who are your users?
Absolutely. No, it's been a hell of a journey since time zero, so to speak, which was essentially effectively launched, which was end of December. And well, the narrative was very clear, right? It was bringing in fairness towards what was the ZK landscape. There was not yet a ZK rollup environment with their own native token. We were the first one on that regard, but we also revolutionized with what is essentially fair launches, right? And I mean, I think we made quite a little bit of noise with what was the fair distribution of ZK Fair as a native ecosystem token, and the fair distribution, which was throughout the utilization of the L2 environment in the first days of launch. Essentially, a gas fee mining, what we mentioned, or gas fee airdrop, what we eventually called it, was a total success. Over $100 million eventually crossed towards our specific L2 environment, just specifically for the event. We hit at peaks of $250 million in TVL, currently sitting at about 150 to 200 million in TVL, and we've been having quite an interesting advancement or development, and this is essentially into finding that identity from the community in itself, because in ZK Fair we really have been very community focused, very community first, and what we have seen is that the predominance of being able to really determine and foment towards fairness and towards fair launches is something that became quite sticky within the ecosystem itself. So something that you have started to see is already fair launches from ecosystem protocols that are determined and are willing to commit towards eventually launching within the ecosystem in itself, and also providing what's essentially the fair launch metrics or structure in itself, right? And we've had 3 protocols so far for fair launches, 2 being very native towards ZK Fair, 1/3 one being also a CDK chain, which is a Merlin chain in this case, that we collaborated with them as well. And it's been quite some advancements on that regard. In terms of community, what we've had so much is really maturation towards what's really an ecosystem that is having the vibration in terms of protocols to be used, whether it's DeFi, whether it's different games that you're seeing in the ecosystem, whether it's different protocols that have been deployed over the last 2 months, and the direction that we're really taking is towards that fairness and really being able to implement that on a next level. And one of the things that we really were bringing on the table from day one and has been implemented as well so far was the profitability distribution. And this is something that was a message also from even before the launch in itself. It's really related towards the profitability of a rollup, and this is something that's not really talked about very often, but different rollup environments, whether optimistic or ZK based, eventually have profitability. In the end, when you look at the amount of gas fees that have been obtained versus the amount or the cost eventually of securing the rollup environments down to a base layer like Ethereum, there's a certain discrepancy, and that discrepancy is exactly what we're distributing back to users ourselves. And the way that we're doing it is throughout ZKF staking, which is of course our native token, but also giving back to developers. And this is specifically a 25% that we do, essentially replaces what is or what would have been a treasury or a foundation that is providing certain incentives to protocols that may be interested in joining this ecosystem. Because in the end, what we have set up is that at protocol level or at rollup level, what you're having is an incentivization of development of developers that are deploying contracts based on usage. What does it mean? What does this mean? Based on usage, all those different protocols, all those different contracts that are being deployed are being rewarded based on that profitability that is being given back. In other words, what you're having is a cash flow that's going directly back to to developers, as long as there is certain degree of usage on their protocols themselves. And I believe that personally, from what we've seen so far, it's a great substitute towards the methodology of grant programs or different approaches that we have seen so far. And it's becoming it's turning to actually become a very feasible solution for us to be able to onboard a very vibrant ecosystem that we're having, which is currently close to 100 different protocols being deployed, being built on top of Mainnet, including the different launch pods and everything, right? So we're expanding on that regard. We're, going little by little, having our bread and butter on a daily basis. But so far, what we're having is an astonishing result, being pretty much on the top 10 across of all the different production environment rollups, including Arbitrum, including Optimism, etc., etc., etc. And slowly, little by little, taking steps forward. Also looking at some new innovative solutions as well, data availability solutions, restaking. There's a lot of things on the modularity aspect that's very interesting, but we're taking things one step at a time. So yeah, if I had to resume a little bit of what's been happening.
Yeah, Alvaro, that's a really big idea. As Sandeep says, sometimes I think it's impossible to know how many different interesting and innovative things are being built on Polygon's networks, on Polygon CDK and on the Polygon technology-based blockchains. So I'm really amazed by how many the whole cool idea of sort of fairness and how many different things can come out of it. I know Vitalik has been has written about fairness. I know Tarun has done some very interesting work on fairness of auctions. So I'm really excited to see where you go with all this. Now, so let's talk about something that's on a slightly different dimension, right? Liquidity. So where is the liquidity coming from, right? So are most of the assets coming from Ethereum layer 1? And this question is for all of you, or where else are the assets kind of flowing in and out from?
I'll just go ahead. So initially, we've seen a lot of Ethereum-based bridging, but as we've seen more maturity, especially within CDK in itself, and also within different rollup environments going out, what we're picturing more and what we're seeing more, and also this bridges a little bit more towards my thought process at Lumos, is aggregated liquidity. Because with different rollup environments having different purposes, different focuses, and different applications running on top, what you really want to see is an aggregation of that liquidity. You don't want to be fragmenting, and when I mean fragmenting, I'm talking about the latency, which is specific towards the fragmentation, to be able to move assets from one side to another. Essentially, what you want to do is be able to reduce that situation. Because if I'm interested in playing a game which is in a Japanese ecosystem, and then I want to move towards an ecosystem which is related to my favorite centralized exchange, I'm just putting two examples that are here on stage. I want that to be at least in a short time basis, right? So seeing that aggregation actually translate towards a better UX is something that's the more we build towards specific environments, towards application-specific environments, and in this case, it's not really the case of ZK Fair, but we've seen that there's plenty of application-specific rollup environments that are coming up. The more you're going to have that dependency of aggregation. So seeing advancements towards that direction is actually going to be crucial for us to be able to coexist in a better manner as well.
No, absolutely. Martin?
Yes, so for us, like our L2 is not launched yet, but we are working with partners like Layer 0 to connect to our L1 to bring the liquidity that we already have on our L1 to bring it as well to our L2. At the same time, we are currently in the final phases as well, working with the Polygon engineers regarding the Egg layer connectivity. So the mainnet will be launched with the Egg layer, and this is where the unified liquidity comes in. And then you don't need to worry about where the liquidity comes from. It comes from the whole pool where everybody is connected with. And this is what we all want to achieve. And there's also what Alvaro was saying, like we don't want the users to think about where to go from next. If they go from chain, it's like this aggregation is really needed to get this adoption of the technology. And this is why we also would like, or we wanted to launch our L2 with this aggregated solutions available. Otherwise, we will also be like isolated in one way, and then we will all be digging in the same pool. Instead of digging in the same pool, but I mean, like on the Ethereum side, let's do it united and let's share all the liquidity that everybody has. And I see a huge benefit. And all the partners here who will be connected as well to that pool, like the ZK Fair and the X1 that is coming with OKX. I think this will be a huge change in the space when it comes to DeFi and all the liquidity.
Yeah, Victor. So I know that there is a few ETH in in Manta that's coming from my hardware wallet, but not that many. Where else is the liquidity coming from? And what sort of patterns have you seen?
Thanks to be part of our liquidity.
Always.
I mean, like, I think generally, like, we really care about capital efficiency. So basically, like, the like, I think the way we start is we start to build a full ecosystem at the beginning. Basically, there's no missing piece. Like, there's blue chip DEX, there's like Lightning Protocol perp DEX, and there's not only one. There's like kind of computation market, but at the beginning there's not many TVL, and we don't have that crazy amount of money raised, compared to other layer two. But the way we doing is we try to attract like Degen's money first, and through the great way of growth, and like the way of we do new paradigm, we give them NFT gets the token reward. This kind of the way is kind of really fun. A lot of people calculate about this, a lot of people try to engage about this, and but the different for us is we actually have a layer 2 compared to Blast. So after they deploy the bridge this like token into the layer 2, we don't even need to do any customer support or education. They just go to the DeFi protocol themselves. So that's kind of how it starts. But besides of that, you can see we are the only one use Hyperline bridge TIA into Manta. So we are the only EVM support TIA token. So all of these new tokens, they launch, in other chain, even it's non-EVM, we can find the ways to bridge that. So that's kind of the capital efficiency we really care about. And right now, there's restaking coming. There's really good traction on AI. We recently have the AI token like ISP, and also we have the restaking, EtherFi deploy on Manta. So there will be more. It will be really fun to see all of this. But besides of that, I'm seeing more and more liquidity coming from centralized exchange. And if you go to Binance, and Binance opened the Ethereum deposit and withdraw of Manta chain. Besides, Arbitrum, OP, and other ZK Sync, they support Manta. So that actually bring a lot of Ethereum from centralized exchange, and that is actually the best bridge.
Yeah, no, absolutely. And it's I think I have a couple of tweets out there saying that centralized exchanges are the first of all, they are great bridges. They're also fantastic layer twos. So in the sense that there are lots of things you can do really, really quickly on top of OKX, the exchange that I think we want to do on chain for more transparency, liquidity, capital efficiency, all those things, and also because that's kind of the future that we're building. But I think of OKX as a fantastic layer 2 and a wonderful bridge, which is truly cross chain, very inexpensive, and so on and so forth. So Chai, what brings you on chain? As in, you have had so much success off chain. Right now, but I think your vision is obviously to kind of drive this Internet of Value forward, and you are also a very big liquidity hub, right? As a centralized exchange, OKX is obviously a very large liquidity hub. So I think you are as much a provider of liquidity as you are as user of liquidity. But right now, in terms of your L2 architecture, how do you see the liquidity flowing across the different ecosystems, and how does CDK kind of and the Ag layer support that?
Yeah. So we are kind of fortunate that we are one of the largest crypto companies, both in terms of centralized exchange as well as Web3 product alliance. So I mean, there are some other chains such as Manta or Blast. They have their own unique strategies, but for us, it's more about how to connect those OKX ecosystem with Ethereum system. So from that perspective, for us, liquidity comes from majorly comes from two
areas. One is our OKX ecosystem, another one is like Polygon, Ethereum ecosystem, or from like broader view EVM ecosystem. We believe like it's eventually like a lot of like I think it's just already happening. A lot more innovations are happening on chain rather than on like centralized exchange. Most of the technologies that centralized exchanges are using, they have been around like for, I don't know, for decades or even centuries. And we are very excited that that there will be like a lot more innovations, a lot of cool ideas, products will be happening on chain, and then that is why we launched our layer 2 to onboard like a lot more users on chain, and then so that they can experience something like that is like a lot more attractive and innovative. And because of that, for us, like centralized exchange, the exchanges, they have their unique ways to like so-called bridging assets or users to on-chain, and we also like are trying to our best to bridge like assets from like other layer 1s or even layer 2s as well. That is why we are like onboarding some of those like bridgers or even cross-chain solutions, and we are even more excited to see that Polygon is working on or even like going to release like egg layer, which like going to aggregate like all of those layer 2s, the powered layer 2s, or even layer 1s. I think that it would be like revolutionary, because even though there are lots of bridging solutions out there, but in terms of the way they do it, in terms of user experience, they are like either siloed or like totally different, which is like absolutely not good for the industry to onboard like huge number of users. So we are super excited to see like this new innovative ideas like so valuable, and we are going to activate that. And I believe with our centralized exchange behind it, our Web3 like product lines behind it, X1 will eventually like our layer 2 will eventually like truly become the bridge, kind of like not that can bridge, but a bridge like connecting like a lot of users, a lot of liquidity with like other ecosystem as well.
Yeah, so I think, see, I come from TradFi, been 10 years in blockchain and crypto now, but so in TradFi, like if you're trading desks at Goldman, you kind of really like the money moving around. You don't want to lock up liquidity or lock up capital because it costs money to lock up liquidity, right? So whereas in crypto, people love it when they will say, oh yeah, we have 10 billion in TVL, we just locked all this money and now we have to pay for it. It's actually a cost to lock up all this liquidity. In TradFi, if you're sort of trading or settling across CLS and all of the other settlement systems, then you want to hold as little liquidity as possible, right? So capital efficiency and the rapid movement of liquidity across different applications is kind of what you pride yourself on, not locking up liquidity. So it's kind of different, but I think that's where we're going to go as this ecosystem matures and sort of crypto matures as a whole. We'll sort of focus a lot more on capital efficiency than on just locking up capital. So I think that's part of why we came up with the Ag layer, to allow seamless movement of liquidity across different applications, but also to create interoperability across, this whole interchain vision actually started in Cosmos. But then Cosmos doesn't solve for shared security, which is kind of what, with even AZ and some of the other solutions are quite limited, whereas Ethereum provides the shared security and the sheer amount of ZK technology and, that we've been able to move forward with the help of others also in the ecosystem in the last 2 years, with Plonky 3 coming out now, right, and SP1, RIS0, lots of other quality startups outside of Polygon also really contributing very, we are collaborating with all of them to drive this technology and ecosystem forward. So with this Ag layer, I think we'll be able to, create that sort of maturity in crypto where we say, look, it's not how much money it's locked up, but it's, how many things we can do with it, right? How users feel are able to move this liquidity painlessly across different ecosystems, and then also create composite applications using asynchronous composability across ZK Fair, A-Star, Manta, OKXL2, and all the other CDK chains. So I think so as I say, right, the Cosmos guys got a lot of things right, but then Ethereum brought two great things to this. One is shared security, the $360 billion worth of Ethereum that secures all of the ZK based validity chains like CDK chains. and then also the ZK technology that will now allow an Ag layer, which will allow Liquidity to move back and forth, and for people to be able to create these composite applications using async composability of the modularity that CDK provides. So I think and you guys are the pioneers. You've done a phenomenal job of building your ecosystems, applications. We are very lucky to have you as as part of the Polygon community, and very grateful for that. But you also bring a lot of technology capability, right? And a lot of the development skills, the engineering chops, all of the great things. And it's quite phenomenal as to how this whole Polygon network state is building up, to see and how much global talent that's coming on board. So, on behalf of the Polygon community, I would really, we are coming to the close of this panel. I would really like to thank you on behalf of the global, the millions of people in the Polygon community, which include me as well. So any last comments before we close? Remarks, thoughts, ideas, anything you want to say to the audience? Alvaro, starting with you.
Just very glad to see how this journey is really moving forward. It seems incredible to think that only 2 months ago was the first launch of a CDK production environment, and that we're already here. And I can't wait to see more excitement for what's coming with not only modularity but aggregation as well.
Yeah, Chai.
I would like to echo your point that like the capital aren't not simply by locked up. It's more about like how it can be moved, not only different like chains, layer 2s, layer 1s, but like even like off chains. That is how capital efficiency. So I think it's more important than like just some kind of data, but like capital just like kind of like dead there. So this is something that we really wanted to achieve, like not simply about like it's just like expressway, not simply how many cars there, but we care more about like how many cars are moving every minute, every day, and how many goods are moving. So this is something that we are really excited about, or we care a lot about. And then I also would like to thank Polygon and Ether Global for hosting this, and very excited to share views with you guys.
Martin, you, and then Victor.
Okay. First of all, thank you for hosting. Thank you for inviting me to be here. What I would like to say to end things off, in the next couple of weeks, we will launch our launch campaign. This will give you the full Japanese experience. We already launched our manga comic that tells the story about our launch campaign. It's about the Yoki origins, where you can really feel the passion that we have from Japan and with Web3. And we will do this with a campaign with all our partners who are connected with us, with the gacha machines, where you can turn around, get a ball, and get a surprise that's in this. It's really exciting. It's a really cool experience that you will have, that will showcase as well the Web3 experience as well for the Web2 users to enjoy Web3 with the whole Japanese look and feel.
Yeah, Martin, I love anime memes, so I'm looking forward to more manga and anime on your Twitter. So Victor, over to you.
Yeah, I mean, like I'm looking forward to see like how the transition going, and yeah, we will keep expanding the ecosystem together.
So much. Thank you to all our busy guests for joining. Thank you for building everything you're building, and it's great to have you as part of our global Polygon network state and community. Thank you so much.
Bye, guys.
Thank you so much, everyone.
Yes, thank you all so much. Thanks, Ajit, for leading this. All right, so next up we have our closing thoughts with Mark from Polygon Labs. But before that happens, just a few quick announcements. You might have been seeing the QR codes on some of these slides. If you're in the audience right now and would like an Ag Day NFT, go ahead and scan that QR code, or go back a little bit in the video to a previous slide where we also have that QR code. Also, we'd like to thank ETH Global for their partnership in this. They have an amazing streaming platform they're using and a complete setup that has made this very, very, very easy for Polygon Labs. They've been very collaborative and great. So thank you so much, ETH Global. And then lastly, come join us in Denver. Go back a little bit in time on Twitter or X to our thread where we list everywhere we're going to be talking. We also have the Ag Cave, as I mentioned. We'd love to see many, many people there. So we're going to go ahead and move on to closing thoughts. And that's going to be with Mark. Mark, can you see me?
Yes, I can.
Awesome. I don't know if you all know this, but Mark is actually challenging all the L2s into a wrestling match, I believe, at ETH Denver. Is that right, Mark?
Yeah. I didn't know you were sharing that, but yeah, I'll be inviting them all to a wrestling match so that I can get piled on.
There you go. There you go. All right, Mark, take it away. Thank you.
All right. So first, Hudson, thank you for doing a really good job of being our leader today. It's been a really good experience. Equally want to thank everyone in the community for joining us. This was somewhat of a long morning for me and maybe afternoon and maybe for some people night. But I think it was really exciting. I think what you could see from our side is a lot of excitement around ZK tech. That is what this entire event ended up being kind of focused around. You know, what you kind of heard, I'll kind of like walk through some like the key things that kind of came out of today that I think were exciting. So first is, you know, we talked about the first component of AgLayer going live and that being this unified bridge. And that unified bridge is one that we're going to start seeing chains connect to. We've got Polygon ZK VM connected there, and soon we'll see CDK chains connecting over there. And that's going to be exciting because we also released this bridge and call function that allows for you know, easy one kind of user transaction being executed across multiple chains and bridging over to those L2s. But I think we also explored a lot more than that with some really amazing participants that I also want to thank for having taken time to be here from other ecosystems and from the Ethereum kind of ecosystem as a whole. But I think some of the things that we heard was first, like the acceleration of kind of ZK tech in general, ZK systems, ZK VMs. It continues to outpace like everybody's expectations, including ours at Polygon Labs. But it was also really cool. We got to talk about some of those collaborations going on. What we see is like everyone building on each other's technology, and that's the power of open source technology. Again, at Polygon Labs, we put everything out on open source licenses. We value it tremendously. It ends up moving kind of our work forward when we rely on other people's work, and same way the other way around. And we are going to continue doing that. And it really ends up moving the entire space forward. I think one of the most exciting panels that I've heard in a really long time was the panel on synchronous composability. And I think there was every single person on that panel had really interesting thoughts. And I would actually say that almost everyone in this space should probably listen to that panel. There was a lot of information to learn from like basic concepts broken down really easily to more complex concepts and really kind of exploring the challenges and opportunities that exist there. And so, you know, anyone who knows people who were not listening, I would encourage them to listen to that. I think the ZK endgame panel was really cool for exploring ZK very comprehensively. We often think of, or most people think of ZK in a very narrow way, either for scalability, for privacy, and really don't think about everything that it offers. And so exploring all those problems that it solves was really cool. Maybe the coolest part was the difficulty that everyone had with actually poking holes in why ZK is the endgame. It took some pretty major assumptions to try to poke holes in that. And that's because I think fundamentally ZK does solve so many of those issues. And then the thing that I will forever say is always near and dear to my heart is CDK chains that are launching, exploring launching, or those who are already in our ecosystem who we're talking. So from ZK Fair to Manta to A-Star to OKX, they're all ramping up either live and just building very quickly or are going to go live very shortly. They all have different approaches that you could kind of see. And these end up being very complementary in a world where you have the interoperability from the ag layer that ultimately is going to let ecosystems leverage other ecosystems. So I often say these are communities that are coming together offline when it comes to working on the same code base and improving it, but also an ecosystem that is coming together online through the connection to the ag layer and really sharing kind of users and liquidity ultimately. So I really appreciate those teams for being on and all the other teams that are building CDK chains. I just love seeing that community continue to grow. So last thing I will kind of finish out with is just thanks again for joining us. Hopefully we'll see you at ETH Denver. And lastly, ETH Global. This was fantastic as always. So appreciate you co-hosting this aggregation day with us. And we are definitely looking to future aggregation days as well. So thank you all for listening again, and we'll be talking soon.